Chapter 11, Part 2 of Aircraft and Submarines by Willis J. Abbott. This LibriVox recording is in the public domain. Recording by William Tomcho. Beginning of Submarine Invention, Part 2. Many and various have been the opinions on this strange, useless, and fatal experiment, though the more reasonable part of mankind seem to give it up as wholly impracticable. It is well known that pent-up air, when overcharged with the vapors emitted out of animal bodies, becomes unfit for respiration, for which reason those confined in the diving bell, after continuing some time under water, are obliged to come up and take in fresh air, or by some such means recruit it. That any man should be able after having sunk a vessel to so great a depth to make that vessel at pressure so much more specifically lighter than water as thereby to enable it to force its way to the surface through the depressure of so great a weight is a matter not hastily to be credited. Even cork, when sunk to a certain depth, will, by the great weight of the fluid upon it, be prevented from rising. The English of the Annual Register leaves much to be desired in clarity. It makes reasonably clear, however, that the unfortunate Mr. Day's knowledge of submarine conditions was, by no means, equal to Mr. Blake's sporting spirit. Even to day 100 feet is an unusual depth of submersion for the largest submarines. The credit for using a submarine boat for the first time in actual warfare belongs to a Yankee, David Bushnell. He was born in Saybrook, Connecticut, and graduated from Yale with the class of 1775. While still in college, he was interested in science, and as far as his means and opportunities allowed, he devoted a great deal of his time and energy to experimental work. The problem which attracted his special attention was how to explode powder under water, and before very long he succeeded in solving this to his own satisfaction as well as to that of a number of prominent people, amongst whom were the Governor of Connecticut and his council. Bushnell's experiments, of course, fell in the period during which the Revolutionary War was fought, and when he had completed his invention there naturally presented itself to him a further problem. How could his device be used for the benefit of his country and against the British ships which were then threatening New York City? As a means to this end, Bushnell planned and built a submarine boat which on account of its shape is usually called the Turtle. General Washington thought very highly of Bushnell, whom he called in a letter to Thomas Jefferson a man of great mechanical powers, fertile in inventions, and master of execution. In regard to Bushnell's submarine boat, the same letter, written after its failure, says, "I thought and still think that it was an effort of genius, but that too many things were necessary to be combined to expect much against an enemy who are always on guard." During the whole period of the building of the Turtle, Bushnell was in ill health. Otherwise he would have navigated it on its trial trip himself, for he was a man of undoubted courage and wrapped up alike in the merits of his invention and in the possibility of utilizing it to free New York from the constant ignominy of the presence of British ships in its harbor. But his health made this out of the question. Accordingly he taught his brother the method of navigating the craft, but at the moment for action the brother too fell ill. It became necessary to hire an operator. This was by no means easy, as volunteers to go below the water in a submarine boat of a type hitherto undreamed of, and to attach an explosive to the hull of a British man of war, the sentries upon which were presumably especially vigilant, being in a hostile harbor, was an adventure likely to attract only the most daring and reckless spirits. In a letter to Thomas Jefferson, other portions of which we shall have occasion to quote later, Bushnell refers to this difficulty in finding a suitable operator, and tells briefly and with evident chagrin the story of the failure of the attempts made to utilize successfully his submarine. After various attempts to find an operator to my wish, I sent one who appeared more expert than the rest from New York to a 50-gun ship lying not far from Governor's Island. He went under the ship and attempted to fix the wooden screw into her bottom, but struck, as he supposes, a bar of iron which passes from the rudder hinge and is spiked under the ship's quarter. Had he moved a few inches, which he might have done without rowing, I have no doubt that he would have found wood where he might have fixed the screw, or if the ship were sheathed with copper he might easily have pierced it. but not being well skilled in the management of the vessel, in attempting to move to another place, he lost the ship. After seeking her in vain for some time, he rowed some distance and rose to the surface of the water, but found daylight had advanced so far that he durst not renew the attempt. He says that he could easily have fastened the magazine under the stern of the ship above water, as he rowed up to the stern and touched it before he descended. Had he fastened it there, the explosion of 150 pounds of powder, the quantity contained in the magazine, must have been fatal to the ship. In his return from the ship to New York, he passed near Governor's Island, and thought he was discovered by the enemy on the island. Being in haste to avoid the danger he feared, he cast off the magazine, as he imagined it retarded him in the swell, which was very considerable. After the magazine had been cast off 1 hour, the time the internal apparatus was set to run, it blew up with great violence. Afterward there were 2 attempts made in Hudson's River, above the city, but they effected nothing. One of them was by the aforementioned person. In going towards the ship he lost sight of her, and went a great distance beyond her. When he at length found her, the tide ran so strong that, as he descended under water for the ship's bottom, it swept him away. Soon after this the enemy went up the river and pursued the boat which had the submarine vessel on board, and sunk it with their shot. Though I afterwards recovered the vessel, I found it impossible at that time to prosecute the design any further. The operator to whom Bushnell had entrusted his submarine boat was a typical Yankee, Ezra Lee of Lyme, Connecticut. His story of the adventure differs but little from that of Bushnell, but it is told with a calm indifference to danger and a seeming lack of any notion of the extraordinary in what he had done that gives an idea of the man. When I rowed under the stern of the ship, the Eagle, I could see the men on deck and hear them talk, he wrote. I then shut down all the doors, sunk down, and came up under the bottom of the ship. This means that he hermetically sealed himself inside of a craft shaped like 2 upper turtle shells joined together, hence the name of the turtle. He had entered through the orifice at the top, whence the head of the turtle usually protrudes. This before sinking he had covered and made watertight by screwing down upon it a brass crown or top like that to a flask. Within he had enough air to support him 30 minutes. The vessel stood upright, not flat as a turtle carries himself. It was maintained in this position by lead ballast. Within, the operator occupied an upright position, half sitting, half standing. To sink water was admitted, which gathered in the lower part of the boat, while to rise again this was expelled by a force pump. There were ventilators and portholes for the admission of light and air when operating on the surface, but once the cap was screwed down the operator was in darkness. In this craft, which suggests more than anything else a curiously shaped submarine coffin, Lee drifted along by the side of the ship, navigating with difficulty with his single oar and seeking vainly to find some spot to which he might affix his magazine. A fact which might have disquieted a more nervous man was that the clockwork of this machine was running and had been set to go off in an hour from the time the voyage was undertaken. As to almost anyone in that position, minutes would seem hours. The calmness of Sailor Lee's nerves seems to be something beyond the ordinary. When he finally abandoned the attempt on the Eagle, he started up the bay. Off Governor's Island he narrowly escaped capture. When I was abreast of the fort on the island, 300 or 400 men got upon the parapet to observe me. At length a number came down to the shore, shoved off a 12-oared barge with 5 or 6 sitters, and pulled for me. I eyed them, and when they had got within 50 or 60 yards of me, I let loose the magazine, in hopes that if they should take me they would likewise pick up the magazine, and then we should all be blown up together. But as kind Providence would have it, they took fright and returned to the island, to my infinite joy. The magazine, after getting a little past the island, went off with a tremendous explosion, throwing up large bodies of water to an immense height. During the last quarter of the 18th and during the first half of the 19th century, France was the chief center for the activities of submarine inventors. However, very few of the many plans put forward in this period were executed. The few exceptions resulted in little else than trial boats, which usually did not live up to the expectations of their inventors or their financial backers and were, therefore, discarded in quick order. In spite of this lack of actual results, this particular period was of considerable importance to the later development of the submarine. Almost every one of the many boats then projected or built contained some innovation, and in this way some of the many obstacles were gradually overcome. Strictly speaking, the net result of the experimental work done during these 75 years by a score or more of men, most of whom were French, though a few were English, was the creation of a more sane and sound basis on which, before long, other men began to build with greater success. The one notable accomplishment of interest, especially to Americans, was a submarine built in 1800–1801 by Robert Fulton. Fulton, of course, is far better known by his work in connection with the discovery and development of steam navigation. Born in Pennsylvania in 1765, he early showed marked mechanical genius. In 1787 he went to England with the purpose of studying art under the famous painter West, but soon began to devote most of his time and energy to mechanical problems. Not finding in England as much encouragement as he had hoped, he went, in 1797, to Paris, and for the next 7 years lived there in the house of the American minister, Joel Barlow. As soon as he had settled down in France, he offered his plans of a submarine boat, which he called the Nautilus, to the French government. Though a special commission reported favorably on this boat, the opposition of the French Minister of the Marine was too strong to be overcome, even after another commission had approved a model built by Fulton. In 1800, however, he was successful in gaining the moral and financial support of Napoleon Bonaparte, then First Consul of the French Republic. Fulton immediately proceeded to build the Nautilus, and completed the boat in May, 1801. It was cigar shaped, about 7 feet in diameter and over 21 feet in length. The hull was of copper strengthened by iron ribs. The most noticeable features were a collapsible mast and sail and a small conning tower at the forward end. The boat was propelled by a wheel affixed to the center of the stern and worked by a hand winch. A rudder was used for steering, and increased stability was gained by a keel which ran the whole length of the hull. Soon after completion, the boat was taken out for a number of trial trips, all of which were carried out with signal success and finally culminated on June 26, 1801, in the successful blowing up of an old ship furnished by the French government. Although the Nautilus created a great sensation, popular as well as official interest began soon to flag. Fulton received no further encouragement and finally gave up his submarine experiments. In 1806 he returned to America. By 1814 he had built another submarine boat which he called the Mute. It was, comparatively speaking, of immense size, being over 80 feet long, 21 feet wide, and 14 feet deep, and accommodating 100 men. It was iron plated on top, and derived its peculiar name from the fact that it was propelled by a noiseless engine. Before its trials could be completed, Fulton died on February 24, 1815, and no one seemed to have sufficient interest or faith in his new boat to continue his work. In the middle of the 19th century, for the first time, a German became seriously interested in submarines. His name was Wilhelm Bauer. He was born in 1822 in a small town in Bavaria, and though a turner by trade, joined the army in 1842. Bauer was even in his youth of a highly inventive turn of mind. He possessed an indomitable will and an unlimited supply of enthusiasm. Step by step he acquired, in what little time he could spare from his military duties, the necessary mechanical knowledge, and finally, supported financially by a few loyal friends and patrons, he built his first submarine at Kiel at a cost of about $2,750. It sank to the bottom on its first trial trip, fortunately without anyone on board. Undaunted, he continued his efforts. When he found that his support at Kiel was weakening, he promptly went to Austria. In spite of glowing promises, opposition on the part of some officials deprived Bauer of the promised assistance. He went then to England, and succeeded in enlisting the interest of the Prince Consort. A boat was built according to Bauer's plans, which, however, he was forced by the interference of politicians to change to such an extent that it sank on its first trial with considerable loss of life. Still, full of faith in his ability to produce a successful submarine, Bauer now went to Russia. In 1855 he built a boat at St. Petersburg and had it accepted by the Russian government. It was called Le Diable Marin and looked very much like a dolphin. Its length was 52 feet, its beam 12 feet 5 inches, and its depth 11 feet. Its hull was of iron. A propeller, worked by 4 wheels, furnished motive power. Submersion and stability were regulated by 4 cylinders into which water could be pumped at will. The first trial of the boat was made on May 26, 1856, and was entirely successful. In later trials as many as 14 men at a time descended in Le Diable Marin. It is said that Bauer made a total of 134 trips on his boat. All but 2 were carried out successfully. At one time, however, the propeller was caught in some seaweed, and it was only by the quickest action that all the water was pumped out and the bow of the boat allowed to rise out of the water, so that the occupants managed to escape by means of the hatchway. Like Fulton in France, Bauer now experienced in Russia a sudden decrease of official interest. When he finally lost his boat, about 4 weeks later, he also lost his courage, and in 1858 he returned to Germany, where he later died in comparative poverty. Contemporary with Bauer submarines and immediately following them were a large number of other boats. Some of these were little more than freaks. Others failed in certain respects, but added new features to the sum total of submarine inventions. As early as 1854, Monsieur Marie Davy, professor of chemistry at Montpellier University, suggested an electromagnetic engine as motive power. In 1855, a well-known engineer, J. Nasmyth, suggested a submerged motor driven by a steam engine. None of the boats of this period proved successful enough, however, to receive more than passing notice, and very few indeed ever reached the trial stage. But before long the rapid development of internal combustion engines and the immense progress made by the study of electricity was to advance the development of submarines by leaps and bounds. End of Beginnings of Submarine Invention, Part 2. Chapter 12, Aircraft and Submarines by Willis J. Abbott. This LibriVox recording is in the public domain. Recording by William Tomcho. The Coming of Steam and Electricity. In the fall of 1863, the Federal fleet was blockading the harbor of Charleston, South Carolina. Included among the many ships was one of the marvels of that period, the United States battleship Ironsides. Armor-plated and possessing what was then considered a wonderful equipment of high-calibered guns and a remarkably trained crew, she was the terror of the Confederates. None of their ships could hope to compete with her, and the land batteries of the southern harbor were powerless to reach her. During the night of October 5, 1863, the officer of the watch on board the Ironsides, Ensign Howard, suddenly observed a small object looking somewhat like a pleasure boat, floating close to his own ship. Before Ensign Howard's order to fire at it could be executed, the Ironsides was shaken from bow to stern, an immense column of water was thrown up and flooded her deck and engine room, and Ensign Howard fell, mortally wounded. The little floating object was responsible for all this. It was a Confederate submersible boat, only 50 feet long and 9 feet in diameter, carrying a 15-foot spar torpedo. She had been named David, and the Confederate authorities hoped to do away by means of her with the Goliaths of the Federal Navy. Manned only by 5 men, under the command of Lieutenant W. T. Glassell, driven by a small engine and propeller, she had managed to come up unobserved within striking distance of the big battleship. The attack, however, was unsuccessful. The Ironsides was undamaged. On the other hand, the plucky little David had been disabled to such an extent that her crew had to abandon her and take to the water, allowing their boat to drift without motive power. 4 of them were later picked up. According to an account in Barnes, Torpedoes and Torpedo Warfare, the engineer, after having been in the water for some time, found himself near her and succeeded in getting on board. He relighted her fires and navigated his little boat safely back to Charleston. There she remained, making occasional unsuccessful sallies against the Federal fleet, and when Charleston was finally occupied by the Federal forces, she was found there. In spite of this failure, the Confederates continued their attempts to break the blockade of their most important port by submarine devices. A new and somewhat improved David was ordered and built at another port. News of this somehow reached the Federal Navy Department and was immediately communicated to Vice Admiral Dahlgren in command of the blockading fleet. Despite this warning and instructions to all the officers of the fleet, the second David succeeded in crossing Charleston Bar. This new boat was a real diving submarine boat, and though frequently called David, had been christened the Hundley. It had been built in the shipyards of McClintock and Hundley at Mobile, Alabama, and had been brought to Charleston by rail. On her trial she proved very clumsy and difficult to manage. For her first trip a crew of 9 men volunteered. Not having any conning tower, it was necessary that one of the hatchways should be left open while the boat traveled on the surface so that the steersman could find his bearings. While she was on her first trip, the swell from a passing boat engulfed her. Before the hatchway could be closed, she filled with water. Of course, she sank like a piece of lead, and her entire crew, with the exception of the steersman, was drowned. In spite of this mishap, the Hundley was raised and again put in commission. Lieutenant Payne, who had steered her on her first fatal trip, had lost neither his courage nor faith, and again assumed command of her. Soon after she started on her second trip, a sudden squall arose. Before the hatchways could be closed, she again filled with water and sank, drowning all of her crew with the exception of Lieutenant Payne and 2 of his men. Undaunted, he took her out on a third trip, after she had again been raised. Ill luck still pursued her. Off Fort Sumter she was capsized, and this time 4 of her crew were drowned. The difficulties encountered in sailing the Hundley on the surface of the water apparently made no difference when it came to finding new crews for her. By this time, however, the powers that be had become anxious that their submarine boat should accomplish something against an enemy instead of drowning only her own men, and it was decided to use her on the next trip in a submerged state. Again Lieutenant Payne was entrusted with her guidance. Her hatches were closed, her water tanks filled, and she was off for her first dive. Something went wrong, however. Either too much water had been put in her tanks, or else the steering gear refused to work. At any rate, she hit the muddy bottom with such force that her nose became deeply embedded, and before she could work herself free, her entire crew of 8 was suffocated. Lieutenant Payne himself lost his life, which he had risked so valiantly and frequently before. Once more she was raised, and once more volunteers rushed to man her. On the 5th trip, however, the Hundley, while traveling under water, became entangled in the anchor chains of a boat she passed, and was held fast so long that her crew of 9 were dead when she was finally disentangled and raised. 35 lives had so far been lost without any actual results having been accomplished. In spite of this, a new crew was found. Her commander, Lieutenant Dixon, was ordered to make an attack against the Federal fleet immediately, using, however, the boat as a submersible instead of a submarine. Admiral David Porter, in his Naval History of the Civil War, described the attack, which was directed against the USS Housatonic, one of the newest Federal battleships, as follows. At about 8:45 P.M., the officer of the deck on board the unfortunate vessel discovered something about 100 yards away, moving along the water. It came directly towards the ship, and within 2 minutes of the time it was first sighted was alongside. The cable was slipped, the engines backed, and all hands called to quarters. But it was too late. The torpedo struck the Housatonic just forward of the mainmast on the starboard side, on a line with the magazine. The man who steered her, the Hundley, knew where the vital spots of the steamer were, and he did his work well. When the explosion took place, the ship trembled all over as if by the shock of an earthquake, and seemed to be lifted out of the water, and then sank stern foremost, heeling to port as she went down. Only a part of the Housatonic's complement was saved. Of the Hundley, no trace was discovered, and she was believed to have escaped. 3 years later, however, divers who had been sent down to examine the hull of the Housatonic found the little submarine stuck in the hole made by her attack on the larger ship, and inside of her the bodies of her entire crew. The submarines and near submarines built in the United States during the Civil War were remarkable rather for what they actually accomplished than for what they contributed towards the development of submarine boats. Perhaps the greatest service which they rendered in the latter direction was that they proved to the satisfaction of many scientific men that submarine boats really held vast possibilities as instruments of naval warfare. France still retained its lead in furnishing new submarine projects. One of these, put forward in 1861 by Olivier Riou, deserves mention because it provided for two boats, one driven by steam and one by electricity. Both of these submarines were built, but inasmuch as nothing is known of the result of their trials, it is safe to conclude that neither of them proved of any practical value. 2 years later, in 1863, two other Frenchmen, Captain Bourgeois and Monsieur Brun, built at Rochefort a submarine 146 feet long and 12 feet in diameter, which they called the Plongeur. They fitted it with a compressed air engine of 80 horsepower. Extensive trials were made with this boat, but resulted only in the discovery that, though it was possible to sink or rise with a boat of this type without great difficulty, it was impossible to keep her at an even keel for any length of time. During the next few years, undoubtedly as a result of the submarine activities during the Civil War, a number of projects were put forward in the United States, none of which, however, turned out successfully. One of them, for which a man by the name of Halstead was responsible, was a submarine built for the United States Navy in 1865. It was not tried out until 1872, and it was not even successful in living up to its wonderful name, the Intelligent Whale. Its first trial almost resulted in loss of life and was never repeated. In spite of this, however, the boat was preserved and may still be seen at the Brooklyn Navy Yard. In the meantime, an invention had been made by an Austrian artillery officer, which before long was to exert a powerful influence on submarine development, though it was in no sense a submarine boat. The manner in which the submarines had attacked their opponents during the Civil War suggested to him the need of improvements in this direction. As a result, he conceived a small launch which was to carry the explosive without any navigators. Before he could carry his plans very far, he died. A brother officer in the Navy continued his work, and finally interested the manager of an English engineering firm located at Fiume, Mr. Whitehead. The result of the collaboration of these two men was the Whitehead torpedo. A series of experiments led to the construction of what was first called a submarine locomotive torpedo, which not only contained a sufficient quantity of explosives to destroy large boats, but was also enabled by mechanical means to propel itself and keep on its course after having been fired. The Austrian government was the first one to adopt this new weapon. Whitehead, however, refused to grant a monopoly to the Austrians, and in 1870 he sold his manufacturing rights and secret processes to the British government for a consideration of $45,000. Before very long, special boats were built for the purpose of carrying and firing these torpedoes, and gradually every great power developed a separate torpedo flotilla. Hand in hand with this development, a large number of improvements were made on the original torpedo, and some of these devices proved of great usefulness in the development of submarine boats. The public interest in submarines grew rapidly at this time. Every man who was a boy in 1873, or who had the spirit of boyhood in him then, or perhaps now, will remember the extraordinary piece of literary and imaginative prophecy achieved by Jules Verne in his novel 20,000 Leagues Under the Sea. Little about the Nautilus that held all readers entranced throughout his story is lacking in the submarines of today, except indeed its extreme comfort, even luxury. With those qualities our submarine navigators have to dispense. But the electric light, as we know it, was unknown in Verne's time, yet he installed it in the boat of his fancy. Our modern internal combustion engines were barely dreamed of, yet they drove his boat. His fancy even enabled him to foresee one of the most amazing features of the lake boat of to-day, namely, the compressed air chamber which open to the sea still holds the water back, and enables a submarine navigator clad in a diver's suit to step into the wall of water and prosecute his labors on the bed of the ocean. Jules Verne even foresaw the callous and inhuman character of the men who command the German submarines today. His Captain Nemo had taken a vow of hate against the world and relentlessly drove the prow of his steel boat into the hulls of crowded passenger ships, finding his greatest joy in sinking slowly beside them with the great glare of his submarine, electric lights turned full upon the hapless women and children over whose sufferings he gloated as they sank. The man who sank the Lusitania could do no more. More and more determined became the attempts to build submarine boats that could sink and rise easily, navigate safely and quickly, and sustain human beings under the surface of the water for a considerable length of time. Steam, compressed air, and electricity were called upon to do their share in accomplishing this desired result. Engineers in every part of the world began to interest themselves in the submarine problem, and as a result submarine boats in numbers were either projected or built between 1875 and 1900. One of the most persistent workers in this period was a well-known Swedish inventor, Nordenfeldt, who had established for himself a reputation by inventing a gun which even today has lost nothing of its fame. In 1881 he became interested in the work which had been done by an English clergyman named Garrett. The latter had built a submarine boat which he called the Resurgam, I shall rise, thus neatly combining a sacred promise with a profane purpose. In 1879 another boat was built by him driven by a steam engine. Nordenfeldt used the fundamental ideas upon which these two boats were based, added to them some improvements of his own, as well as some devices which had been used by Bushnell, and finally launched it in 1886, his first submarine boat. The government of Greece bought it after some successful trials. Not to be outdone, Greece's old rival, Turkey, immediately ordered two boats for her own navy. Both of these were much larger than the Greek boat, and by 1887 they had reached Constantinople in sections where they were to be put together. Only one of them, however, was ever completed. Characteristic Turkish delay intervened. The most typical feature of this boat was the fact that it carried a torpedo tube for Whitehead torpedoes. On the surface of the water this boat proved very efficient, but as an underwater boat it was a dismal failure. More than in any other craft that had ever been built and accepted, the lack of stability was a cause of trouble in the Nordenfeldt II. As soon as any member of the crew moved from one part of the boat to another, she would dip in the direction in which he was moving, and everybody who could not in time take hold of some part of the boat came sliding and rolling in the same direction. When finally such a tangle was straightened out, only a few minutes elapsed before somebody else, moving a few steps, would bring about the same deplorable state of affairs. The Nordenfeldt II acted more like a bucking bronco than a self-respecting submarine boat, and as a result it became impossible to find a crew willing to risk their lives in manning her. Before very long she had rusted and rotted to pieces. In spite of this lack of success, Nordenfeldt built a fourth boat which displayed almost as many unfortunate features as her predecessors, and soon was discarded and forgotten. In the latter part of the 19th century the French government, which for so many years had shown a strong and continuous interest in the submarine problem, was particularly active. Three different types of boats built in this period under the auspices and with the assistance of the French government deserve particular attention. The first of these was the Gymnote, planned originally by a well-known French engineer, Dupuy de Lome, whose alert mind also planned an airship and made him a figure in the history of our Panama Canal. He died, however, before his project could be executed. Monsieur Gustave Zédé, a marine engineer and his friend, continued his work after modifying some of his plans. The French Minister of Marine of this period, Admiral Aube, who had long been strongly interested in submarines, immediately accepted Monsieur Zédé's design and ordered the boat to be built. As the earliest of successful submarines, she merits description. The Gymnote was built of steel in the shape of a cigar. She was 59 feet long, 5 feet 9 inches beam, and 6 feet in diameter, just deep enough to allow a man to stand upright in the interior. The motive power was originally an electromotor of 55 horsepower driven from 564 accumulators. It was of extraordinary lightness, weighing only 4,410 pounds, and drove the screw at the rate of 2,000 revolutions a minute, giving a speed of 6 knots an hour, its radius of action at this speed being 35 miles. Immersion was accomplished by the introduction of water into 3 reservoirs, placed one forward, one aft, and one center. The water was expelled either by means of compressed air or by a rotary pump worked by an electromotor. 2 horizontal rudders steered the boat in the vertical plane, and an ordinary rudder steered in the horizontal. The Gymnote had her first trial on September 4, 1888, and the Paris Temps described the result in the following enthusiastic language: "She steered like a fish, both as regards direction and depth. She mastered the desired depth with ease and exactness. At full power she attained the anticipated speed of from 9 to 10 knots. The lighting was excellent. There was no difficulty about heating. It was a strange sight to see the vessel skimming along the top of the water suddenly give a downward plunge with its snout and disappear with a shark-like wriggle of its stern, only to come up again at a distance out and in an unlooked-for direction. A few small matters connected with the accumulators had to be seen to, but they did not take a month." Following along the same lines as this boat, another boat, considerably larger, was built. Before it was completed, M. Zédé died, and it was decided to name the new boat in his honor. The Gustave Zédé was launched at Toulon on June 1, 1893. She was 159 feet in length, beam 12 feet 4 inches, and had a total displacement of 266 tons. Her shell was of Roma bronze, a non-magnetic metal, and one that could not be attacked by sea water. The motive power was furnished by 2 independent electromotors of 360 horsepower each and fed by accumulators. In order to endow the boat with a wide radius of action, a storage battery was provided. The successive crews of the Gustave Zédé suffered much from the poisonous fumes of the accumulators, and during the earlier trials all the men on board were ill. In the bows was a torpedo tube, and an arrangement was used whereby the water that entered the tube after the discharge of the torpedo was forced out by compressed air. 3 Whitehead torpedoes were carried. In spite of the fact that a horizontal rudder placed at the stern had not proved serviceable on the Gymnote, such a rudder was fitted in the Gustave Zédé. With this rudder she usually plunged at an angle of about 5 degrees, but on several occasions she behaved in a very erratic fashion, seesawing up and down, and once, when the committee of experts were on board, she proved so capricious, going down at an angle of 30 to 35 degrees, often throwing the poor gentleman on to the floor, that it was decided to fix a system of 6 rudders, 3 on each side. 4 water tanks were carried, 1 at each end and 2 in the middle, and the water was expelled by 4 pumps worked by a little electromotor. These pumps also furnished the air necessary for the crew and for the discharge of the torpedoes. For underwater vision, an optical tube and a periscope had been provided. On July 5, 1899, still another submarine boat was launched for the French Navy. She was called the Morse. She was 118 feet long, 9 feet beam, displaced 146 tons, and was likewise made of Roma bronze. The motive power was electricity, and in many other respects she was very similar to the Gustave Zédé, embodying, however, a number of improvements. M. Calmette, who accompanied the French Minister of War on the trial trip of the Morse, described his experience in the Paris Figaro as follows: "General André, Dr. Vincent, a naval doctor, and I entered the submarine boat Morse through the narrow opening in the upper surface of the boat. Our excursion was to begin immediately. In 2 hours we came to the surface of the water again 3 miles to the north to rejoin the Narval. Turning to the crew, every man of which was at his post, the commandant gave his orders, dwelling with emphasis on each word. A sailor repeated his orders one by one, and all was silent. The Morse had already started on its mysterious voyage, but was skimming along the surface until outside the port in order to avoid the numerous craft in the arsenal. To say that at this moment, which I had so keenly anticipated, I did not have the tremor which comes from contact with the unknown would be beside the truth. On the other hand, calm and imperturbable, but keenly curious as to this novel form of navigation, General André had already taken his place near the commandant on a folding seat. There were no chairs in this long tube in which we were imprisoned. Everything was arranged for the crew alone, with an eye to serious action. Moreover, the Minister of War was too tall to stand upright beneath the iron ceiling, and in any case it would be impossible to walk about. The only free space was a narrow passage 60 centimeters broad, less than 2 meters high, and 30 meters long, divided into 3 equal sections. In the first, in the forefront of the tube, reposed the torpedoes, with a machine for launching them, which at a distance of from 500 to 600 meters were bound to sink, with the present secret processes, the largest of ironclads. In the second section were the electric accumulators which gave the light and power. In the third, near the screw, was the electric motor which transformed into movement the current of the accumulators. Under all this, beneath the floor, from end to end, were immense water ballasts, which were capable of being emptied or filled in a few seconds by electric machines, in order to carry the vessel up or down. Finally, in the center of the tube, dominating these 3 sections, which the electric light inundated and which no partition divided, the navigating lieutenant stood on the lookout giving his orders. There was but one thing which could destroy in a second all the sources of authority, initiative, and responsibility in this officer. That was the failure of the accumulators. Were the electricity to fail, everything would come to a stop. Darkness would overtake the boat and imprison it forever in the water. To avoid any such disaster, there had been arranged, it is true, outside the tube and low down, a series of lead blades which were capable of being removed from within to lighten the vessel. But admitting that the plunger would return to the surface, the boat would float hither and thither, and at all events lose all its properties as a submarine vessel. To avoid any such disaster, a combination of motors had been in course of construction for some months, so that the accumulators might be loaded afresh on the spot, in case of their being used up. The Morse, after skimming along the surface of the water until outside the port, was now about to sink. The commandant's place was no longer in the helmet or kiosk, whence he could direct the route along the surface of the sea. His place was henceforth in the very center of the tube, in the midst of all sorts of electric manipulators, his eyes continually fixed on a mysterious optical apparatus, the periscope. The other extremity of this instrument floated on the surface of the water, and whatever the depth of the plunge, it gave him a perfectly faithful and clear representation, as in a camera, of everything occurring on the water. The most interesting moment of all now came. I hastened to the little opening to get the impression of total immersion. The lieutenant, by the marine chart, verified the depths. The casks of water were filled, and our supply of air was thereby renewed from their stores of surplus air. In our tiny observatory, where General André stationed himself above me, a most unexpected spectacle presented itself as the boat was immersed. The plunge was so gentle that in the perfect silence of the waters one did not perceive the process of descent, and there was only an instrument capable of indicating, by a needle, the depth in which the Morse was penetrating. The vessel was advancing while at the same time it descended, but there was no sensation of either advance or roll. As to respiration, it was as perfect as in any room. M. de Lanessan, who since entering office has ordered 8 more submarine vessels, had concerned himself with the question as a medical man also, and, thanks to the labors of a commission formed by him, the difficulties of respiration were entirely solved. The crew were able to remain under water 16 hours without the slightest strain. Our excursion on this occasion lasted scarcely 2 hours. Towards noon, by means of the mysterious periscope, which, always invisible, floated on the surface and brought to the vessel below a reflection of all that passed up above, the captain showed us the Narval, which had just emerged with its 2 flags near the old battery Impregnable. From the depths in which we were sailing, we watched its slightest maneuvers until the admiral's flag, waving on the top of a fort, reminded us that it was time to return. End of The Coming of Steam and Electricity, recorded by William Tomcho. Chapter 13, Aircraft and Submarines by Willis J. Abbott. This LibriVox recording is in the public domain. Recording by William Tomcho. John P. Holland and Simon Lake, Part 1. The Naval Committee of the House of Representatives of the United States in the early part of 1900 held a meeting for the purpose of hearing expert testimony upon the subject of submarines. Up to then, the United States authorities had shown, as compared with the ruling powers of other navies, only a limited amount of interest in the submarine question. Increased appropriations for the construction of submarine boats, which were then beginning to become more frequent in other countries, acted, however, as a stimulus at this time. The committee meeting took place a few days after some of the members of the committee, together with a number of United States Navy officers, had attended an exhibition of a new submarine boat, the Holland No. 9. The late Admiral Dewey gave the following opinion about this submarine to the committee, an opinion which since then has become rather famous. "Gentlemen, I saw the operation of the boat down off Mount Vernon the other day. Several members of this committee were there. I think we were very much impressed with its performance. My aide, Lieutenant Caldwell, was on board. The boat did everything that the owners proposed to do. I said then, and I have said it since, that if they had two of those things at Manila, I could never have held it with the squadron I had. The moral effect, to my mind, it is infinitely superior to mines or torpedoes or anything of the kind. With two of those in Galveston, all the navies of the world could not blockade the place." Admiral Dewey's approval of the Holland No. 9 undoubtedly exerted a considerable influence on the Naval Committee, and as a result of its recommendations, the United States Government finally purchased the boat on April 11, 1900, for $150,000. This amount was about $86,000 less than the cost of building to the manufacturers, the Holland Torpedo Boat Company. The latter, however, could well afford to take this loss, because this first sale resulted a few months afterwards, on August 25th, in an order for 6 additional submarines. The British government also contracted in the fall of the same year for 5 Hollands. The navy of almost every power interested in submarines soon followed the lead of the British Admiralty. Submarines of the Holland type were either ordered outright, or else arrangements were concluded permitting the use of the basic patents held by the Holland Company. It will be noted that the United States Government, having discovered that it had a good thing, benevolently shared it with the governments that might be expected to use it against us. The Holland No. 9, as her very name indicates, was one of a long line of similar boats. As compared with other experimental submarine boats, she was small. She was only 53 feet 10 inches long and 10 feet 7 inches deep. Although these proportions made her look rather thick-set, they were the result of experimental work done by the builder during a period of 25 years. She was equipped both with a gasoline engine of 50 horsepower and an electric motor run by storage batteries. The latter was intended for use when the boat was submerged, the former when she was traveling on the surface of the water. She was capable of a maximum speed of 7 knots an hour. Her cruising radius was 1,500 miles, and the combination of oil and electric motors proved so successful that from that time on every submarine built anywhere adopted this principle. 2 horizontal rudders placed at the stern of the boat steered her downward whenever she wanted to dive, and so accomplished a diver was this boat that a depth of 28 feet could be reached by her in 5 seconds. Her conning tower was the only means of making observations. No periscopes had been provided, because none of the instruments available at that time gave satisfaction. This meant that whenever she wished to aim at her target, it was necessary for her to make a quick ascent to the surface. Her stability was one of her most satisfactory features. So carefully had her proportions been worked out that there was practically no pitching or rolling when the boat was submerged. Even the concussion caused by the discharge of a torpedo was hardly noticeable, because arrangements had been made to take up the recoil caused by the firing and to maintain the balance of the boat by permitting a quantity of water equal to the weight of the discharged torpedo to enter special compartments at the very moment of the discharge. The Holland No. 9 was built at Lewis Nixon's shipyards at Elizabethport, New Jersey, and was launched early in 1898, just previous to the outbreak of the Spanish-American War. Although numerous requests were made to the United States Government by her inventor and builder, John P. Holland, for permission to take her into Santiago harbor in an attempt to torpedo Cervera's fleet, the Navy authorities at Washington refused this permission. Why? Presumably through Navy hostility to the submarine idea. When the Monitor whipped the Merrimac in 1862, the former ship belonged to her inventor, not to the United States Government. It would have been interesting had Holland at his own expense destroyed the Spanish ships. John P. Holland, at the time when he achieved his success, was 58 years old, Irish by birth and an early immigrant to the United States. He had been deeply interested for many years in mechanical problems, and especially in those connected with navigation. The change from the old wooden battleships to the new ironclads and the rapidly increasing development of steam engines acted as a strong stimulus to the young Irishman's experiments. It is claimed that his interest in submarine navigation was due primarily to his desire to find a weapon strong enough to destroy or at least dominate the British Navy, for at that time Holland was strongly anti-British, because he, like many other educated Irishmen of that period, desired before everything else to free Ireland. His plans for doing this by supplying to the proposed Irish Republic a means for overcoming the British Navy found little support and a great deal of ridicule on the part of his Irish friends. In spite of this, he kept on with his work, and in 1875 he built and launched his first submarine boat at Paterson. This boat was far from being very revolutionary. She was only 16 feet long and 2 feet in diameter, shaped like a cigar, but with both ends sharply pointed. In many respects, except in appearance, she was similar to Bushnell's Turtle. Room for only one operator was provided, and the latter was to turn the propeller by means of pedals to be worked by his feet. She accomplished little beyond giving an opportunity to her inventor and builder to gather experience in actual underwater navigation. 2 years later, in 1877, the Holland No. 2 was built. In spite of the number of improvements represented by her, she was not particularly successful. Her double hull, it is true, provided space for carrying water ballast, but the leaks from this ballast tank continuously threatened to drown the navigator sitting inside of the second hull. A small oil engine of 4 horsepower was soon discarded on account of its inefficiency. The experience gathered by Holland in building and navigating these two boats strengthened his determination to build a thoroughly successful submarine and increased his faith in his ability to do so. He opened negotiations with the Fenian Brotherhood. This was a secret society founded for the purpose of freeing Ireland from British rule, and creating an Irish Republic. Holland finally succeeded in persuading his Fenian friends to order from him 2 submarine boats and to supply him with the necessary means to build them. Both of these boats were built. The lack of success of the first one was due primarily to the inefficiency of her engine. The second boat, which was really the Holland No. 4, was built in 1881. It is usually known as the Fenian ram, and is still in existence at New Haven, Connecticut, where a series of financial and political complications finally landed her. These 2 boats added vastly to Holland's knowledge concerning submarine navigation. A few others which he built with his own means increased this fund of knowledge, and step by step he came nearer to his goal. By 1888 his reputation as a submarine engineer and navigator had grown to such an extent that Holland was asked by the famous Philadelphia shipbuilders, the Cramps, to submit to them designs for a submarine boat to be built by the United States Government. Only one other design was submitted, and this was by the Scandinavian Nordenfeld. William C. Whitney, then Secretary of the United States Navy, accepted Holland's design. Month after month passed by, wasted by the usual government red tape, and when all preliminary arrangements had been made and the contract for the actual building of an experimental boat was to be drawn up, a sudden change in the administration resulted in the dropping of the entire plan. Holland's faith in the future submarine and in his own ability was still unshaken, but this was not the case with his financial condition. None of the boats he had built so far had brought him any profits, and on some he had lost everything that he had put into them. His financial support, for which he relied entirely upon relatives and friends, was practically exhausted. But fortunately, on March 3, 1893, Congress appropriated a sum of money to defray the expenses of constructing an experimental submarine. Invitations to inventors were extended. So precarious was Holland's financial condition at that time that he found it necessary to borrow the small sum of money involved in making plans which he had to submit. It is claimed that he succeeded in doing this in a manner highly typical of his thoroughness. He needed only about $350, but even this comparatively small sum was more than he had. However, he happened to be lunching with a young lawyer just about this time and began to tell him about his financial difficulties. Holland told him that if he only had $347.19, he could prepare the plans and pay the necessary fees. And that done, he was sure of being able to win the competition. His lawyer friend, of course, had been approached before by other people for loans. Invariably, they had asked him for some round sum, and Holland's request for $347.19, when he might just as well have asked for $350, aroused his interest. He asked the inventor what the 19 cents were to be used for. Quick as a flash, he was told that they were needed to pay for a particular type of ruler necessary to draw the required plans. So impressed was the lawyer with Holland's accuracy and honesty in asking not a cent more than he actually needed that he at once advanced the money. And a good investment it turned out to be. For in exchange he received a good-sized block of stock in the Holland Torpedo Boat Company, which in later years made him a multi-millionaire. Holland's plans did win the competition just as he asserted that they would, but, of course, winning a prize, offered by a government, and getting that government to do something about it are two different matters. So 2 years went by before the Holland Torpedo Boat Company at last was able to start with the construction of the new submarine, which was to be called the Plunger. The principal feature of this new boat was that it was to have a steam engine for surface navigation and an electric motor for underwater navigation. This arrangement was not so much a new invention of Holland's as an adaptation of ideas which had been promulgated by others. Especially indebted was he in this respect to Commander Hovgaard of the Danish Navy, who, in 1887, had published an important book on the subject of double propulsion in submarines. Though Holland had made many improvements on these earlier theories, he soon found out that even at that there was going to be serious trouble with the Plunger's engines. The boat had been launched in 1897, but instead of finishing it, he persuaded the government to permit his company to build a new boat, and to return to the government all the money so far expended on the Plunger. The new boat, Holland No. 8, was started immediately and completed in record time, but she too was unsatisfactory to the inventor. So without loss of time he went ahead and built another boat, the Holland No. 9, which, as we have said, became the first United States submarine. 2 other men submitted plans for submarine boats in the competition which was won by the Holland boat, George C. Baker and Simon Lake. Neither of these was accepted. Mr. Baker made no further efforts to find out if his plans would result in a practicable submarine boat, but Simon Lake was not so easily discouraged. It is very interesting that the United States Navy Department at that time demanded that plans submitted for this competition should meet the following specifications: 1. Safety. 2. Facility and certainty of action when submerged. 3. Speed when running on the surface. 4. Speed when submerged. 5. Endurance, both submerged and on the surface. 6. Stability. 7. Visibility of object to be attacked. In spite of the many years that have passed since this competition, and in spite of the tremendous progress that has been made in submarine construction, these are still the essential requirements necessary to make a successful submarine boat. The design submitted by Mr. Lake provided for a twin-screw vessel, 80 feet long, 10 feet beam, and 115 tons displacement, with 400 horsepower steam engines for surface propulsion and 70 horsepower motors for submerged work. The boat was to have a double hull, the spaces between the inner and the outer hulls forming water ballast tanks. There were to be 4 torpedo tubes, 2 forward and 2 aft. In an article published in 1915 in International Marine Engineering, Mr. Lake says about his 1893 design: The new and novel feature which attracted the most attention and skepticism regarding this design was, the author was later informed by a member of the board, the claim made that the vessel could readily navigate over the water bed itself, and that while navigating on the water bed a door could be opened in the bottom of a compartment and the water kept from entering the vessel by means of compressed air, and that the crew could, by donning diving suits, readily leave and enter the vessel while submerged. Another novel feature was in the method of controlling the depth of submergence when navigating between the surface and water bed. The vessel was designed to always submerge and navigate on a level keel, rather than to be inclined down or up by the back to dive or rise. This maintenance of a level keel while submerged was provided for by the installation of 4 depth-regulating vanes which I later termed hydroplanes to distinguish them from the forward and aft leveling vanes or horizontal rudders. These hydroplanes were located at equal distances forward and aft of the center of gravity and buoyancy of the vessel when in the submerged condition, so as not to disturb the vessel when the planes were inclined down or up to cause the vessel to submerge or rise when under way. I also used, in conjunction with the hydroplanes, horizontal rudders, which I then called leveling vanes, as their purpose was just the opposite from that of the horizontal rudder used in the diving type of vessel. They were operated by a pendulum controlling device to be inclined so as to always maintain the vessel on a level keel rather than to cause her to depart therefrom. When I came to try this combination out in practice, I found hand control of the horizontal rudders was sufficient. If vessels with this system of control have a sufficient amount of stability, you will run for hours and automatically maintain both a constant depth and a level keel, without the depth control man touching either the hydroplane or horizontal rudder control gear. This automatic maintenance of depth without manipulating the hydroplanes or rudders was a performance not anticipated nor claimed in my original patent on the above mentioned combination, and what caused these vessels to function in this manner remained a mystery, which was unsolved until I built a model tank in 1905 in Berlin, Germany, and conducted a series of experiments on models of submarines. I then learned that a down pull of a hydroplane at a given degree of inclination varied according to its depth of submergence, and that the deeper the submergence, the less the down pull. This works out to give automatic trim on a substantially level keel, and I have known of vessels running for a period of 2 hours without variation of depth of 1 foot, and without once changing the inclination of either the hydroplanes or the horizontal rudder. A great deal of skepticism was displayed for many years toward this new system of controlling the depth of submergence, but in recent years all the latest submarine boats have been built on this plan. Who, then, was this mechanical genius who was responsible for these far-going changes in submarine construction? Simon Lake was born at Pleasantville, New Jersey, September 4, 1866. He was educated at Clinton Liberal Institute, Fort Plain, New York, and Franklin Institute, Philadelphia. Early in life he displayed a marked interest in and genius for mechanical problems. His lack of success in the 1893 competition only spurred him on to further efforts. As long as the United States Government was unwilling to assist him in building a submarine boat, there was nothing left for him except to build it from his own means. In 1894, therefore, he set to work on an experimental boat called the Argonaut, Jr. According to Mr. Lake's description as published in International Marine Engineering in a series of articles from his pen, the Argonaut, Jr. was provided with 3 wheels, 2 on either side forward and 1 aft, the latter acting as a steering wheel. When on the bottom, the wheels were rotated by hand by 1 or 2 men inside the boat. Her displacement was about 7 tons, yet she could be propelled at a moderate walking gait when on the bottom. She was also fitted with an airlock and diver's compartment, so arranged that by putting an air pressure on the diver's compartment equal to the water pressure outside, a bottom door could be opened and no water would come into the vessel. Then, by putting on a pair of rubber boots, the operator could walk around on the sea bottom and push the boat along with him, and pick up objects, such as clams, oysters, etc., from the sea bottom. So much interest was aroused by this little wooden boat that Mr. Lake was enabled to finance the building of a larger boat, called the Argonaut. It was designed in 1895 and built in 1897 at Baltimore. Concerning the Argonaut, Mr. Lake says in the same article: "The Argonaut, as originally built, was 36 feet long and 9 feet in diameter. She was the first submarine to be fitted with an internal combustion engine. She was propelled with a 30 horsepower gasoline (petrol) engine driving a screw propeller. She was fitted with 2 toothed driving wheels forward, which were revolved by suitable gearing when navigating on the water bed, or they could be disconnected from this gearing and permitted to revolve freely, propulsion being secured by the screw propeller. A wheel in the rudder enabled her to be steered in any direction when on the bottom. She also had a diving compartment to enable divers to leave or enter the vessel when submerged, to operate on wrecks, or to permit inspection of the bottom or to recover shellfish. She also had a lookout compartment in the extreme bow, with a powerful searchlight to light up a pathway in front of her as she moved along over the water bed. This searchlight I later found of little value except for night work in clear water. In clear water the sunlight would permit of as good vision without the use of the light as with it, while if the water was not clear no amount of light would permit of vision through it for any considerable distance." In January, 1898, says Mr. Lake, "while the Argonaut was submerged, telephone conversation was held from submerged stations with Baltimore, Washington, and New York. In 1898 also the Argonaut made the trip from Norfolk to New York under her own power and unescorted. In her original form she was a cigar shaped craft with only a small percentage of reserve buoyancy in her surface cruising condition. We were caught out in the severe November northeast storm of 1898, in which over 200 vessels were lost, and we did not succeed in reaching a harbor in the horseshoe back of Sandy Hook until, of course, in the morning. The seas were so rough they would break over her conning tower in such masses I was obliged to lash myself fast to prevent being swept overboard. It was freezing weather, and I was soaked and covered with ice on reaching harbor. This experience caused me to apply to the Argonaut a further improvement for which I had already applied for a patent. This was, doubled around the usual pressure resisting body of a submarine, a ship-shaped form of light plating which would give greater seaworthiness, better surface speed, and make the vessel more habitable for surface navigation. It would, in other words, make a sea-going submarine, which the usual form of cigar-shaped vessel was not, as it would not have sufficient surface buoyancy to enable it to rise with the seas, and the seas would sweep over it as they would sweep over a partly submerged rock. The Argonaut was, therefore, taken to Brooklyn, 20 feet added to her length, and a light water-tight buoyancy superstructure of ship-shaped form added. This superstructure was open to the sea when it was desired to submerge the vessel, and water was permitted to enter the space between the light plating of the ship-shaped form and the heavy plating of the pressure-resisting hull. This equalized pressure on the light plates and prevented their becoming deformed due to pressure. The superstructure increased her reserve of buoyancy in the surface cruising condition from about 10% to over 40%, and lifted right up to the seas like any ordinary type of surface vessel instead of being buried by them in rough weather. This feature of construction has been adopted by the Germans, Italians, Russians, and in all the latest types of French boats. It is the principal feature which distinguishes them in their surface appearance from the earlier cigar-shaped boats of the diving type. This ship-shaped form of hull is only suited to the level keel submergence. End of John P. Holland and Simon Lake, Part 1. Recording by William Tomcho. Chapter 13 of Aircraft and Submarines by Willis J. Abbott. This LibriVox recording is in the public domain. Recording by William Tomcho. John P. Holland and Simon Lake, Part 2. In those days submarine boats were a much more unusual sight than they are today, and simple fishermen who had never read or heard about submarines undoubtedly experienced disturbing sensations when they ran across their first underwater boat. Mr. Lake, a short time ago, while addressing a meeting of electrical engineers in Brooklyn, told the following experience which he had on one of his trips in the Argonaut. On the first trip down the Chesapeake Bay, we had been running along in 40 feet of water and had been down about 4 hours. Night was coming on, so we decided to come up to find out where we were. I noticed one of those Chesapeake bug eyes lighting just to leeward of us, and as I opened the conning tower hatch, called to the men aboard to find out where we were. As soon as I did so, he turned his boat around and made straight for the beach. I thought he was rather discourteous. He ran his boat up on that beach and never stopped. The last I saw of him was when he jumped ashore and started to run inland as hard as he and his helper could go. Finally, I learned we were just above the mouth of the York or Rappahannock River, and I found a sort of inland harbor back of it. I decided to put up there for the night. Then, learning that there was a store nearby, we called after dark for more provisions, and I noticed a large crowd there. We got what we wanted and stepped outside the door. He asked us where we were from. "We are down here in the submarine boat, Argonaut, making an experimental trip down the bay." He then commenced to laugh. "That explains it," he said. "Just before nightfall, Captain So-and-so and his mate came running up here to the store just as hard as they could, and both dropped down exhausted. And when we were able to get anything out of them, they told a very strange story. That's why all these people are here." This is the story the storekeeper told me. "The men were out dredging, and all at once they noticed a buoy with a red flag on it, and that buoy was going against the tide, and they could not understand it. It came up alongside, and they heard a puff, puff, something like a locomotive puffing, and then they smelled sulphur. The puff, puff was the exhaust of our engine, and those fumes were what they thought was sulphur. Just then the thing rose up out of the water. Then the smokestack appeared, and then the devil came right out of that smokestack." In the January 1899 issue of McClure's Magazine there appeared a profusely illustrated article entitled "Voyaging Under the Sea." The first part of it, "The Submarine Boat Argonaut and Her Achievements," was written by Simon Lake himself. In it he quotes as follows from the log book of the Argonaut under the date of July 28, 1898: "Submerged at 8:20 A.M. in about 30 feet of water. Temperature in living apartment 83 degrees Fahrenheit. Compass bearing west-northwest 1/4 west. Quite a lively sea running on the surface, also strong current. At 10:45 A.M. shut down engine, temperature 88 degrees Fahrenheit. After engine was shut down, we could hear the wind blowing past our pipes extending above the surface. We could also tell by the sound when any steamers were in the vicinity. We first allowed the boat to settle gradually to the bottom, with the tide running ebb. After a time the tide changed, and she would work slightly sideways. We admitted about 400 pounds of water additional, but she still would move occasionally, so that a pendulum 9 inches long would sway 1/8 of an inch thwart ship. At 12 o'clock noon temperature was 87 degrees Fahrenheit. At 2:45 P.M. the temperature was still 87 degrees Fahrenheit. There were no signs of carbonic acid gas at 2:45, although the engine had been closed down for 3 hours and no fresh air had been admitted during the time. Could hear the whistle of boats on the surface, and also their propellers when running close to the boat. At 3:30 the temperature had dropped to 85 degrees. At 3:45 found a little sign of carbonic acid gas, very slight, however, as a candle would burn fairly bright in the pits. Thought we could detect a smell of gasoline by comparing the fresh air which came down the pipe when hand blower was turned. Storage lamps were burning during the 5 hours of submergence, while engine was not running. At 3:50 engine was again started and went off nicely. Went into diving compartment and opened door, came out through air lock and left pressure there. Found the wheels had buried about 10 inches or 1 foot, as the bottom had several inches of mud. We had 500 pounds of air in the tanks, and it ran the pressure down to 250 pounds to open the door in about 30 feet. The temperature fell in the diving compartment to 82 degrees after the compressed air was let in. Cooked clam fritters and coffee for supper. The spirits of the crew appeared to improve the longer we remained below. The time was spent in catching clams, singing, trying to waltz, playing cards, and writing letters to wives and sweethearts. Our only visitors during the day were a couple of black bass that came and looked in at the windows with a great deal of apparent interest. In future boats it will be well to provide a smoking compartment, as most of the crew had their smoking apparatus already as soon as we came up. Started pumps at 6:20 and arrived at the surface at 6:30. Down altogether 10 hours and 15 minutes. People on pilot boat, Calvert, thought we were all hands drowned. The second part of this article was called "A Voyage on the Bottom of the Sea." It was written by Ray Stannard Baker, who had been fortunate enough to receive an invitation from Mr. Lake to accompany him on one of the trips of the Argonaut. Anyone who has read Jules Verne's fascinating story, 20,000 Leagues Under the Sea, must be struck immediately with the similarity between Mr. Baker's experiences and those of Captain Nemo's guests. It is not at all surprising, therefore, to have Mr. Baker tell us that during this trip Mr. Lake told him, "When I was 10 years old I read Jules Verne's 20,000 Leagues Under the Sea, and I have been working on submarine boats ever since." Mr. Baker's record of what he saw and how he felt is not only a credit to his keen powers of observation, but also a proof of the fact that in many ways there was little difference between the Argonaut of 1898 and the most up-to-date submarine of to day. In part he says: Simon Lake planned an excursion on the bottom of the sea for October 12, 1898. His strange amphibian craft, the Argonaut, about which we had been hearing so many marvels, lay off the pier at Atlantic Highlands. Before we were near enough to make out her hulk, we saw a great black letter A, framed of heavy gas pipe, rising 40 feet above the water. A flag rippled from its summit. As we drew nearer, we discovered that there really wasn't any hulk to make out, only a small oblong deck shouldering deep in the water and supporting a slightly higher platform, from which rose what seemed to be a squatty funnel. A moment later we saw that the funnel was provided with a cap somewhat resembling a tall silk hat, the crown of which was represented by a brass binnacle. This cap was tilted back, and as we ran alongside, a man stuck his head up over the rim and sang out, "Ahoy there!" A considerable sea was running, but I observed that the Argonaut was planted as firmly in the water as a stone pillar, the big waves splitting over her without imparting any perceptible motion. We scrambled up on the little platform and peered down through the open conning tower, which we had taken for a funnel, into the depths of the ship below. Wilson had started his gasoline engine. Mr. Lake had taken his place at the wheel, and we were going ahead slowly, steering straight across the bay toward Sandy Hook and deeper water. The Argonaut makes about 5 knots an hour on the surface, but when she gets deep down on the sea bottom, where she belongs, she can spin along more rapidly. The Argonaut was slowly sinking under the water. We became momentarily more impressed with the extreme smallness of the craft to which we were trusting our lives. The little platform around the conning tower on which we stood, in reality the top of the gasoline tank, was scarcely a half dozen feet across, and the Argonaut herself was only 36 feet long. Her sides had already faded out of sight, but not before we had seen how solidly they were built, all of steel, riveted and reinforced, so that the wonder grew how such a tremendous weight, when submerged, could ever again be raised. I think we made some inquiries about the safety of submarine boats in general. Other water compartments had been flooded, and we had settled so far down that the waves dashed repeatedly over the platform on which we stood, and the conning tower was still wide open, inviting a sudden engulfing rush of water. "You mustn't confuse the Argonaut with ordinary submarine boats," said Mr. Lake. "She is quite different and much safer." He explained that the Argonaut was not only a submarine boat, but much besides. She not only swims either on the surface or beneath it, but she adds to this accomplishment the extraordinary power of diving deep and rolling along the bottom of the sea on wheels. No machine ever before did that. Indeed, the Argonaut is more properly a sea motorcycle than a boat. In its invention, Mr. Lake elaborated an idea which the United States Patent Office has decided to be absolutely original. We found ourselves in a long, narrow compartment, dimly illuminated by yellowish green light from the little round glass windows. The stern was filled with Wilson's gasoline engine and the electric motor, and in front of us, toward the bow, we could see through the heavy steel doorways of the diver's compartment into the lookout room, where there was a single round eye of light. I climbed up the ladder of the conning tower and looked out through one of the glass ports. My eyes were just even with the surface of the water. A wave came driving and foaming entirely over the top of the vessel, and I could see the curiously beautiful sheen of the bright summit of the water above us. It was a most impressive sight. Mr. Lake told me that in very clear water it was difficult to tell just where the air left off and the water began. But in the muddy bay where we were going down, the surface looked like a peculiarly clear, greenish pane of glass moving straight up and down, not forward, as the waves appear to move when looked at from above. Now we were entirely under water. The rippling noises that the waves had made in beating against the upper structure of the boat had ceased. As I looked through the thick glass port, the water was only 3 inches from my eyes, and I could see thousands of dainty, semi-translucent jellyfish floating about as lightly as thistledown. They gathered in the eddy behind the conning tower in great numbers, bumping up sociably against one another and darting up and down with each gentle movement of the water, and I realized that we were in the domain of the fishes. Jim brought the government chart, and Mr. Lake announced that we were heading directly for Sandy Hook and the open ocean. But we had not yet reached the bottom, and John was busily opening valves and letting in more water. I went forward to the little steel cuddy hole in the extreme prow of the boat and looked out through the watch port. The water had grown denser and yellower, and I could not see much beyond the dim outlines of the ship's spar reaching out forward. Jim said that he had often seen fishes come swimming up wonderingly to gaze into the port. They would remain quite motionless until he stirred his head, and then they vanished instantly. Mr. Lake has a remarkable photograph which he took of a visiting fish, and Wilson tells of nurturing a queer flat crab for days in the crevice of one of the view holes. At that moment I felt a faint jolt, and Mr. Lake said that we were on the bottom of the sea. Here we were running as comfortably along the bottom of Sandy Hook Bay as we would ride in a Broadway car, and with quite as much safety. Wilson, who was of a musical turn, was whistling Down Went McGinty, and Mr. Lake, with his hands on the pilot wheel, put in an occasional word about his marvelous invention. On the wall opposite there was a row of dials which told automatically every fact about our condition that the most nervous of men could wish to know. One of them shows the pressure of air in the main compartment of the boat. Another registers vacuum, and when both are at zero, Mr. Lake knows that the pressure of the air is normal, the same as it is on the surface, and he tries to maintain it in this condition. There are also a cyclometer, not unlike those used on bicycles, to show how far the boat travels on the wheels, a depth gauge, which keeps us accurately informed as to the depth of the boat in the water, and a declension indicator. By the long finger of the declension dial we could tell whether we were going uphill or down. Once, while we were out, there was a sudden sharp shock. The pointer leaped back and then quivered steady again. Mr. Lake said that we had probably struck a bit of wreckage or an embankment, but the Argonaut was running so lightly that she had leaped up jauntily and slid over the obstruction. We had been keeping our eyes on the depth dial, the most fascinating and interesting of any of the number. It showed that we were going down, 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 literally down to the sea in a ship. When we had been submerged for more than an hour, and there was 30 feet of yellowish-green ocean over our heads, Mr. Lake suddenly ordered the machinery stopped. The clacking noises of the dynamo ceased, and the electric lights blinked out, leaving us at once in almost absolute darkness and silence. Before this we had found it hard to realize that we were on the bottom of the ocean. Now it came upon us suddenly, and not without a touch of awe. This absence of sound and light, this unchanging motionlessness and coolness, this absolute negation, that was the bottom of the sea. It lasted only a moment, but in that moment we realized acutely the meaning and joy of sunshine and moving winds, trees, and the world of men. A minute light twinkled out like a star, and then another and another, until the boat was bright again, and we knew that among the other wonders of this most astonishing of inventions there was storage electricity which would keep the boat illuminated for hours, without so much as a single turn of the dynamo. With the stopping of the engine, the air supply from above had ceased, but Mr. Lake laid his hand on the wheel wall above us, where he said there was enough air compressed to last us all for 2 days, should anything happen. The possibility of something happening had been lurking in our minds ever since we started. What if your engine should break down, so that you couldn't pump the water out of the water compartments? I asked. Here we have hand pumps, said Mr. Lake promptly, and if those failed, a single touch of this lever would release our iron keel, which weighs 4,000 pounds, and up we would go like a rocket. I questioned further, only to find that every imaginable contingency, and some that were not at all imaginable to the uninitiated, had been absolutely provided against by the genius of the inventor. And everything, from the gasoline engine to the hand pump, was as compact and ingenious as the mechanism of a watch. Moreover, the boat was not crowded. We had plenty of room to move around and to sleep if we wished, to say nothing of eating. As for eating, John had brought out the kerosene stove and was making coffee, while Jim cut the pumpkin pie. "This isn't Delmonico's," said Jim, "but we're serving a lunch that Delmonico's couldn't serve, a submarine lunch." By this time the novelty was wearing off, and we sat there at the bottom of the sea drinking our coffee with as much unconcern as though we were in an uptown restaurant. For the first time since we started, Mr. Lake sat down, and we had an opportunity of talking with him at leisure. He is a stout-shouldered, powerfully built man in the prime of life, a man of cool common sense, a practical man who is also an inventor. And he talks frankly and convincingly, and yet modestly, of his accomplishment. Having finished our lunch, Mr. Lake prepared to show us something about the practical operations of the Argonaut. It has been a good deal of a mystery to us how workmen penned up in a submarine boat could expect to recover gold from wrecks in the water outside, or to place torpedoes, or to pick up cables. "We simply open the door, and the diver steps out on the bottom of the sea," Mr. Lake said, quite as if he was conveying the most ordinary information. At first it seemed incredible, but Mr. Lake showed us the heavy, riveted door in the bottom of the diver's compartment. Then he invited us inside with Wilson, who, besides being an engineer, is also an expert diver. The massive steel doors of the little room were closed and barred, and then Mr. Lake turned a cock and the air rushed in under high pressure. At once our ears began to throb, and it seemed as if the drums would burst inward. "Keep swallowing," said Wilson, the diver. As soon as we applied this remedy the pain was relieved, but the general sensation of increased air pressure, while exhilarating, was still most uncomfortable. The finger on the pressure dial kept creeping up and up, until it showed that the air pressure inside of the compartment was nearly equal to the water pressure without. Then Wilson opened a cock in the door. Instantly the water gushed in, and for a single instant we expected to be drowned there like rats in a trap. "This is really very simple," Mr. Lake was saying calmly. "When the pressure within is the same as that without, no water can enter." With that Wilson dropped the iron door, and there was the water and the muddy bottom of the sea within touch of a man's hand. It was all easy enough to understand, and yet it seemed impossible, even as we saw it with our own eyes. Mr. Lake stooped down and picked up a wooden rod having a sharp hook at the end. This he pulled along the bottom. We were now rising again to the surface, after being submerged for more than 3 hours. I climbed into the conning tower and watched for the first glimpse of the sunlight. There was a sudden fluff of foam, the ragged edge of a wave, and then I saw, not more than 100 feet away, a smack bound toward New York under full sail. Her rigging was full of men, gazing curiously in our direction, no doubt wondering what strange monster of the sea was coming forth for a breath of air. End of John P. Holland and Simon Lake, Part 2. Recording by William Tomcho. Chapter 14 of Aircraft and Submarines by Willis J. Abbott. This LibriVox recording is in the public domain. Recording by William Tomcho. The Modern Submarine Part 1. Holland and Lake must be considered the fathers of the modern submarine. This claim is not made in a spirit of patriotic boastfulness, though of course it is true that the latter was an American by birth and the former by choice, and that, therefore, we, as a nation, have a right to be proud of the accomplishments of these two fellow citizens of ours. Without wishing to detract anything from the value of the work done by many men in many countries towards the development of the submarine after and contemporaneously with Holland and Lake, it still remains true that the work which these two did formed the foundation on which all others built. Today, no submarine worthy of the name, no matter where it has been built and no matter where and how it is used, is without some features which are typical of either the Holland or Lake type. In many instances, and this is true especially of submarines of the highest type and the greatest development, the most significant characteristics of the Holland and Lake boats have been combined. During the years that followed the small beginnings of Holland and Lake, vast and highly efficient organizations have been built up to continue and elaborate their work. Death claimed Mr. Holland shortly after the outbreak of the Great War, on August 12, 1914. Mr. Lake, in 1917, was still personally connected with and the guiding spirit of the extensive industrial establishments which have been created at Bridgeport, Connecticut. As a result of his inventions, he, too, surrounded himself with a corps of experts who, in cooperation with him, have brought the Lake submarines to a point of perfection which at the time of the Argonaut's first trip would have appeared all but impossible. Roughly speaking, the beginning of the 20th century may be called the turning point in the history of submarine invention and the beginning of the modern submarine. Although, as we have heard, various governments, especially those of France and the United States, interested themselves in the submarine question and appropriated small sums of money towards its solution previous to 1900, it was only after that year that governmental interest and influence were set to work with determination and purpose on behalf of submarine inventors. Quite naturally, this resulted in increased popular interest. Experimental work on and with submarines no longer had to rely exclusively on private capital, frequently inconveniently timid and limited, but could count now on the vast financial resources of all the great nations of the world. This also made available the unlimited intellectual resources of serious scientists in every part of the universe. Mechanical and electrical engineers, naval designers and constructors, active men of finance and business, and quiet thinkers and investigators in laboratories began to interest themselves in the further development of the submarine. The United States for a number of years after its adoption of the Holland type remained true to its first choice. Between 1900, when the first Holland boat was bought by the United States government, and 1911, all the United States submarine boats were of the Holland type. In the latter year, however, it was decided to give the Lake boat a trial, and since that time a number of boats of this type have been built. In all essential features, both the Holland and Lake boats of later days were very similar to the original boats of these two types. In all the details, however, immense progress was made. Each new boat thus became greatly superior to its predecessors. This was especially true in regard to size and speed, and the improvements made in these two respects naturally resulted in a corresponding increase in radius of activity. The passing years also brought a wonderful refinement of all the technical details of the submarine boats. Practically every feature was developed to a remarkable degree. There is, indeed, a great difference between the submarine boats of the early 20th century, which had to rely on their conning tower for steering, and more recent boats with their wonderful periscopes and gyro compasses. Similar progress was made in the development of the means of propulsion. The engines used for surface traveling became more powerful and efficient. This was also true of the electric motors, batteries, and accumulators employed in the submerged state. The problem of ventilation likewise has been worked out to such an extent that in the most modern submarines most of the inconveniences experienced by the crews of earlier boats have been removed. This perfection of technical details which was thus gradually approached also permitted a very considerable increase in the fighting power of submarine boats. The number of torpedo tubes was increased, and it became possible to carry a larger reserve stock of torpedoes. Submarines of to day furthermore carry guns varying in caliber, attaining in some instances 4 inches, and when in later years it became evident that one of the most dangerous enemies of the submarine was the airplane, some of the boats were equipped even with anti-aircraft guns. In the United States Navy the submarine has never been popular. Indeed, it is by no means certain that in comparison with other navies of the world, the United States was not better off in underwater boats in 1911 than she was 3 years later when the war cloud broke. The bulk of our naval opinion has always been for the dreadnoughts. A change of political administration at Washington in 1912 gave a temporary setback to naval development, and the submarines, being still a matter of controversy, languished. Few were built, and of those few many showed such structural weakness that the reports of their manoeuvres were either suppressed or issued in terms of such broad generality that the public could by no possibility suspect, what all the Navy knew to be the fact, that the submarine flotilla of the United States was weak to the point of impotence. Happily we had nearly 3 years in which to observe the progress of the war before becoming ourselves embroiled in it. During this period our submarine fleet was somewhat increased, and upon our actual entrance upon the struggle a feverish race was begun to put us on an equality with other nations in underwater boats. It would have been too late had any emergency arisen, but Germany had no ships afloat to be attacked by our submarines had we possessed them. Her own warfare upon our merchant shipping could not be met in kind, for submarines cannot fight submarines. We have, therefore, up to the present time, not suffered from the perilous neglect with which we long treated this form of naval weapon. Indeed, the submarine fleet of the United States Navy at the beginning of the war was so inconsiderable that foreign writers on the subject ignored it. In 1900 we had purchased 9 of the type of submarines then put out by the Holland Company. One of these, the first in actual service, known as the Baby Holland, was kept in commission 10 years, and upon becoming obsolete was honored by being taken in state to the Naval Academy at Annapolis and there mounted on a pedestal for the admiration of all comers. She was 59 feet long and would make a striking exhibit placed next to one of the new German submersible cruisers which exceed 300 feet and have a displacement of 5,000 tons. These first Holland ships, which long constituted the entire underwater force of the United States, were but trivial affairs compared with the modern vessel. Their displacement was but 122 tons. Their engines for surface navigation were of 160 horsepower, gasoline, and for underwater navigation 70 horsepower, electric. They carried but 1 torpedo tube and 2 extra torpedoes and had a radius of action of but 300 miles. At that time, in fact, the naval theory was that submarines were coast defense vessels altogether. After this war they are likely to form part of the first battle line of every navy. Yet these pioneer vessels established their seaworthiness well in 1911, when 4 of them, accompanied by a parent ship to supply them with fresh stocks of fuel and to render assistance in case of need, crossed the Pacific Ocean under their own power to the Philippines. This exploit tended to popularize these craft in the Navy Department, and soon after larger vessels known as the Viper class were ordered. One of these was called the Octopus, the first submarine to be fitted with twin screws. In many ways she represented a distinct advance in the art of submarine construction. She was in fact the first vessel built with the distinct idea of being a cruising as well as a harbor defense ship. Her type proved successful in this respect. The Octopus further established a record for deep sea submergence in 1907 when she descended to a depth of 205 feet off Boston, returning to the surface in entire safety. The ability to withstand the pressure of the water at great depths is a vital quality of a successful submarine. One American submarine narrowly escaped destruction because of structural weakness in this respect. She had by accident descended a few feet below the normal depth at which such boats navigate. The water pressure affected the valves which refused to work, and the vessel slowly sank deeper and deeper. At a recorded depth of 123 feet, the sinking of the vessel became so much more rapid that the crew with frantic endeavors sought at once to stop the leaks and pump out the water which had entered. At that depth there was a pressure of 153½ pounds upon every square inch of the surface of the submarine. This the workers at the one hand pump had to overcome. It was a savage and a desperate struggle, but the men finally won and the vessel regained the surface. As a result of this experience, every navy prescribed submergence tests for its submarines before putting them into commission. How to make these tests was perplexing at first. A government did not want to send men down in a steel casket to see just how far they could go before it collapsed. But if no observer accompanied the ship, it would be impossible to tell at what depth leakage and other signs of weakness became apparent. An Italian naval architect, Major Laurenti, whose submarines are now found in every navy of the world, invented a dock in which these tests can be made up to any desired pressure, while the observers inside the submarine are in communication with those without, and the pressure can be instantly removed if signs of danger appear. In the United States Navy, boats to be accepted must stand a pressure equivalent to that encountered at 200 feet. In the German Navy the depth prescribed is 170 feet. Under normal conditions submarines seldom travel at a depth of more than 100 feet, although the F-1 of the United States Navy accomplished the remarkable feat of making a 6-hour cruise in San Francisco Bay at a depth of 283 feet. At this depth the skin of the ship has to withstand a pressure of no less than 123 pounds per square inch. Specific information as to the nature of submarine construction in the United States since the beginning of the war in 1914 is jealously guarded by the Navy Department. In broad general terms the number of ships under construction is revealed to the public, but all information as to the size of individual vessels, their armor, or the qualities of novelty with which everyone hopes and believes American inventive genius has invested them, are kept secret. The Navy Yearbook of 1916 summarized our submarine strength at that time as follows: Submarines fit for action 42, displacement 15,722 tons. Submarines under construction 33, displacement 21,093 tons. Submarines authorized and appropriated for 30, displacement 22,590 tons. Total 105, displacement 59,405 tons. In addition, 37 more had been authorized by Congress without the appropriation of money for them. By this time, however, these appropriations have been made together with further heavy ones. While figures are refused at the Navy Department, it is declared that while the United States in 1914 was the last of the great powers in respect to submarine strength provided for, it is now well up to the foremost, even to Germany. Great Britain, like the United States, continued for many years to build submarines of the Holland type. Naturally, all the recent improvements were incorporated in the British boats. Very little, however, is known concerning the details of the more recent additions to the British submarine flotilla because of the secrecy maintained by the British authorities in wartime. At the beginning of the present war, the British Navy possessed 82 active submarines of 5 different classes. They were all of the Holland type, but in each class there were incorporated vast improvements over the preceding class. Displacement, size, motive power, speed, radius of action, and armament were gradually increased until the E class contained boats possessing the following features: submerged displacement 800 tons, length 176 feet, beam 22½ feet, heavy oil engines of 2,000 horsepower, electric engines of 800 horsepower, surface speed 16 knots, submerged speed 10 knots, cruising range 5,000 miles, armament 4 torpedo tubes, space for 6 torpedoes, and 2 3-inch quick-firing, high-angle disappearing guns, armored conning towers and decks, wireless equipment, 3 panoramic periscopes. At the same time 22 other submarines were said to be in course of construction. Some of these were of the F class, Holland type, similar to the E class, except that every single characteristic had been greatly increased, in many instances even doubled. In addition to the F class Holland type boats, there were also under construction a number of boats of different types designated respectively as V, W, and S class. The V class were of the Lake type, the W of the French La Boeuf type, and the S class of the Italian Fiat or Laurenti type. Both of the last named were adaptations of the Lake type. France, which was for many years the prodigal of the nations when it came to submarine building, has continued this tendency. In a way, this liberal expenditure of money did not pay particularly well, for although it resulted in the creation of a comparatively large submarine fleet, this fleet contained boats of every kind and description. Quite a number of the boats were little more than experiments, and possessed not a great deal of practical value. The manning and efficient handling of a fleet having so little homogeneity naturally was a difficult matter and seriously restricted its fighting efficiency. At the outbreak of the war, France had 92 submarines in active service, belonging to 12 different classes. In addition, there had also been built at various times 5 experimental boats which had been named Argonaut, Admiral Bourgeois, Archimede, Marriott, and Charles Brune. The majority of the boats belonging to the various classes were of the La Boeuf type, an adaptation of the Lake type made for the French Navy by M. La Boeuf, a marine engineer. In their various details these boats vary considerably. Their displacement ranges from 67 tons to 1,000 tons, their length from 100 feet to 240 feet, their beam from 12 feet to 20 feet, their surface speed from 8½ knots to 17½ knots, their submerged speed from 5 knots to 12 knots, the horsepower of their heavy oil engines from 1,300 to 2,000, and that of their electric motors from 350 to 900. Some of the boats, however, have steam engines, others gasoline motors, and still others steam turbines. The cruising range of the biggest and newest boats is 4,000 miles. Armament varies with size, of course, the latest boats carrying 4 torpedo tubes for 8 18-inch torpedoes and 2 14 PDR quick-firing, high-angle, disappearing guns. 9 more submarines were in course of construction at the outbreak of war, most of which were of the improved Gustave Zédé class. During the war, French shipyards were chiefly occupied with capital navy ships, and it is not thought the submarine strength has been much increased. Of the great naval powers, Germany was, strangely enough, the last to become interested in the building of a submarine fleet. This, however, was not due to any neglect on the part of the German naval authorities. It is quite evident from the few official records which are available that they watched and studied very carefully the development of the submarine and growth of the various submarine fleets. During the early years of the 20th century, however, the Germans seemed to think that most of the boats that were being built then had not yet passed through the experimental stage, and they also apparently decided that it would be just as well to wait until other nations had spent their money and efforts on those quasi-experimental boats. Not until submarines had been built in the United States, England, and France, which had proved beyond all doubt that they were practicable vessels of definite accomplishments, did the Germans seriously concern themselves with the creation of a German submarine fleet. When this period had been reached, they went ahead with full power, and with the usual German thoroughness they adopted the best points from each of the various types developed by that time. The result of this attitude was a submarine boat built at first exclusively by Krupp, and known as the Germania type. It was this type which formed the basis of the German submarine, which has become known so extensively and disastrously during recent years. In most respects this type is perhaps more similar to the Lake type than to any other, although some features of the Holland type have been incorporated as well. At the beginning of the war, Germany was credited with only 30 submarines. 6 more were then rapidly approaching completion, and the German naval law passed some time before provided for the building of 72 submarines by the end of 1917. It is believed, in fact, that by that time the Germans had not less than 200 Unterseeboots. From the very beginning the Germans have designated their submarines by the letter U, standing for Unterseeboot, followed by numbers. Their first boat was built in 1905 and was named U-1. It was a comparatively small boat of 236 tons displacement. The motive power on the surface was a heavy oil engine of 250 horsepower. Under water the boat was driven by electric motors of a little more than 100 horsepower. Submerged, the UN was capable of a speed of 7 knots only, which on the surface of the water could be increased to 10. Her radius of action was about 750 miles. Only one torpedo tube had been provided. From this boat to the modern German submarine was indeed a long step taken in a comparatively short time. Not very much is known regarding modern German submarines, but the latest boats completed before the war were vessels of 900 tons displacement with heavy oil engines of 2,000 horsepower, and electric motors of 900 horsepower, possessing a surface and submerged speed of 18 and 10 knots respectively and a cruising radius of 4,000 miles. They had 4 torpedo tubes for 8 torpedoes, 2 14 PDR quick-firing guns, and 2 1 PDR high-angle anti-aircraft guns. Naturally, they were also equipped with all the latest improvements, such as wireless apparatus, panoramic periscopes, armored conning towers, and decks. Since the outbreak of the war the Germans have built even more powerful submarine boats whose perfections in regard to speed, radius of action, and armament became known through their accomplishments. Of these we will hear more in a later chapter. At just what period of the war the Germans woke up to the vital importance to them of an enormous submarine fleet is not known. It may have been immediately upon the amazing exploit of Captain Wettingen in the North Sea. At any rate, the war had not long progressed before the destruction caused by German submarine attacks began to awaken the apprehension of the Allies and neutral nations. Retaliation in kind was impossible. The Germans had neither merchant nor naval ships at sea to be sunk. The rapidity with which the volume of the loss inflicted upon merchant shipping grew indicated an equally rapid increase in the size of the German underwater fleet. Neutrals were enraged by the extension by the Germans of the area of sea in which they claimed the right to sink neutral ships, and their growing disregard for the restraining principles of international law. How greatly they developed the submarine idea was shown by their construction in 1916 of vessels with a displacement of 2,400 tons, a length of 279 feet, and a beam of 26 feet. A surface speed of 22 knots, cruising radius of 6,500 miles, mounting 4 to 8 guns, and carrying a crew of from 40 to 60. But it was reported that 2 vessels designed primarily for surface cruising, but nevertheless submersible at will, had been laid down of 5,000 tons, a length of 414 feet, and a radius of 18,000 to 20,000 miles. These submersible cruisers, as they were called, mounted 6 to 8 guns, 30 torpedo tubes, and carried 90 torpedoes. What part vessels of this type shall play in war is still to be determined. End of The Modern Submarine, Part 1. Recording by William Tomcho. Chapter 14 of Aircraft and Submarines, Part 2, by Willis J. Abbott. This LibriVox recording is in the public domain. Recording by William Tomcho. The Modern Submarine, Part 2. Of the smaller naval powers, Italy comparatively early had become interested in the building of submarines. Most of her boats are of the Laurenti type, which is a very close adaptation of the Lake type. Russia and Japan, especially the latter, built up fairly efficient underwater fleets. The lesser countries like Austria, Holland, Sweden, Denmark, Norway, and Spain have concerned themselves seriously with the creation of submarine fleets. The submarine boats of all of these countries in most instances were either of the Lake or Holland type, though frequently they were built from plans of English, French, or German adaptations rather than in accordance with the original American plans. The exact number of submarines possessed now by the various navies of the world is a matter of rather indefinite knowledge. Great secrecy has been maintained by every country in this respect. From a variety of sources, however, it has been possible to compile the following list, which at least gives an approximate idea of the respective strength of the various submarine fleets at the beginning of the war. The numbers assigned to each country are only approximate, however, and include both boats then in existence or ordered built. United States, 57. Great Britain, 104. France, 92. Germany, 36. Italy, 28. Russia, 40. Japan, 15. Austria, 12. Holland, 13. Denmark, 15. Sweden, 13. Norway, 4. Greece, 2. Turkey, 2. Brazil, 3. Peru, 2. Having traced the development of the submarine from its earliest beginnings to recent times, we are naturally now confronted with the question, what are the principal requirements and characteristics of the modern submarine? The submarine boat of to day, in order to do its work promptly and efficiently, must first of all possess seaworthiness. This means that no matter whether the sea is quiet or rough, the submarine must be able to execute its operations with a fair degree of accuracy and promptness, and must also be capable of making continuous headway. Surface and underwater navigation must be possible with equal facility, and it is necessary that a state of submergence can be reached without loss of time and without any degree of danger to the boat's safety. At all times, traveling above water or below, the submarine must possess mechanical means which will make it possible to control its evolutions under all conditions. Furthermore, the ability of the submarine to find and to observe objects in its vicinity must not be greatly reduced when it is in a submerged position. In the latter it also becomes of extreme importance that the provisions for ventilation are such that the crew of the submarine should lose as little as possible in its efficiency and comfort. A fair amount of speed both on and below the surface of the water is essential, and the maintenance of the speed for a fairly long period of time must be assured. In regard to their general outward appearance, submarines of various types to day vary comparatively little. In many respects they resemble closely in shape torpedo boats, the earlier submarine particularly. In size, of course, they differ in accordance with the purposes for which they have been designed. As compared with earlier submarines, the most notable difference is that modern submarines possess more of a superstructure. Almost all of them are built now with double hulls. The space between the outer and the inner hull is utilized primarily for ballast tanks, by means of which submergence is accomplished and stability maintained and regulated. Some of these tanks, however, are not used to carry water ballast, but serve as reservoirs for the fuel needed by the engines. The stability of the submarine and the facility with which it can submerge also depend greatly on the distribution of weight of its various parts. This problem has been worked out in such a way that to day there is little room for improvement. Its details, however, are of too technical a nature to permit discussion in this place. Hydroplanes both fore and aft are now generally used to assist in regulating and controlling stability in the submerged state. The motive power of the modern submarine is invariably of a twofold type. For traveling on the surface, internal combustion engines are used. The gasoline engine of former years has been displaced by Diesel motors or adaptations of them. Although these represent a wonderful advance over the engines used in the past, there is still a great deal of room for improvement. The opinions of engineers in this respect vary greatly, American opinion being generally unfavorable to the Diesel type, and whether the final solution of this problem will lie in the direction of a more highly developed motor of Diesel type, of an improved gasoline engine, or of some other engine not yet developed, only the future can tell. Simplicity of construction and reliability of operation are the two essential features which must be possessed by every part of the power plant of a submarine. For underwater travel, electric motors and storage batteries are employed exclusively. These vary, of course, in detail. In principle, however, they are very much alike. Although this combination of electric and oil power is largely responsible for having made the submarine what it is to day, it is far from perfect. Mechanical complications of many kinds and difficulties of varying degrees result from it. Up to comparatively recently these were considered insurmountable obstacles, but engineers all over the world are giving their most serious attention to the problem of devising a way to remove these obstacles, and continuous progress is made by them. As an immediate result of the development of motive power in the submarine, its speed both on and below the surface of the water, as well as its radius of action, has been materially increased. To day submarines travel on the water with a speed which even a few years ago would have been thought quite respectable for the most powerful battleships or the swiftest passenger liners. And even under water submarines attain a velocity which is far superior to that of which earlier submarines were capable on the surface of the water. How immensely extended the radius of action of the submarine has become in recent years has impressed itself on the world especially in the last few years. Both English and French submarines have traveled without making any stops from their home ports to the Dardanelles and back again. And used to and satiated as we are with mechanical wonders of all kinds, the whole world was amazed when in 1916 German submarines made successful trips from their home ports to ports in the United States, and returned with equal success. This meant a minimum radius of action of 3,500 miles. In the case of the German U boat, which in 1916 appeared at Newport for a few hours, then attacked and sank some merchantmen off the United States coast, and later was reported as having arrived safely in a German port, it has never been established whether the boat renewed its supply of food and fuel on the way, or carried enough to make the trip of some 7,000 miles. One other important feature without which submarines would have found it impossible to score such accomplishments is the periscope. In the beginning periscopes were rather crude appliances. They were very weak and sprung leaks frequently. Moisture, formed by condensation, made them practically useless. In certain positions the image of the object picked up by the periscope became inverted. Their radius of vision was limited, and in every way they proved unreliable and unsatisfactory. But, just as almost every feature of submarine construction was gradually developed and most every technical obstacle overcome, experts gradually concentrated their efforts on the improvement of periscopes. Modern periscopes are complicated optical instruments which have been developed to a very high point of efficiency. A combination of prisms and lenses makes it possible now to see true images clearly. Appliances have been developed to make the rotation of the periscope safe, prompt, and easy, so that the horizon can be swept readily in every direction. Magnification can be established at will by special devices easily connected or disconnected with the regular instrument. The range of vision of the modern periscope is as remarkable as its other characteristics. It differs, of course, in proportion to the height to which the periscope is elevated above the surface of the water. In clear weather a submarine, having elevated its periscope to a height of 20 feet, can pick up a large battleship at as great a distance as 6 miles, while observers on the latter, even if equipped with the most powerful optical instruments, are absolutely unable to detect the submarine. This great distance is reduced to about 4,000 yards if the periscope is only 3 feet above the surface of the water, and to about 2,200 yards if the elevation of the periscope is 1 foot. But even the highly developed periscope of to day, usually called panoramic periscope, has its limitations. The strain on the observer's eyes is very severe and can be borne only for short periods. In dirty weather the objectives become cloudy and the images are rendered obscure and indefinite, although this trouble has been corrected, at least in part, by forcing a strong blast to the rim surrounding the observation glass. At night, of course, the periscope is practically useless. Formerly a shot which cut off the periscope near the water's edge might sink the boat. This has been guarded against by cutting off the tube with a heavy plate of transparent glass which does not obstruct vision but shuts off the entrance of water. Important as the periscope is, both as a means of observing the surroundings of the submarine and as a guide in steering it, it is not the only means of accomplishing the latter purpose. Today every submarine possesses the most reliable type of compass available. At night, when the periscope is practically useless, or in very rough weather, or in case the periscope has been damaged or destroyed, steering is done exclusively by means of the compass. The latest type in use now on submarines is called the gyroscope compass, which is a highly efficient and reliable instrument. In the matter of ventilation, the modern submarine also has reached a high state of perfection. The fresh air supply is provided and regulated in such a manner that most of the discomforts suffered by submarine crews in times past have been eliminated. The grave danger which formerly existed as a result of the poisonous fumes emanating from the storage batteries and accumulators has been reduced to a minimum. In every respect, except that of space, conditions of life in a submarine have been brought to a point where they can be favorably compared with those of boats navigated on the surface of the water. Of course, even at its best, living quarters in a submarine will always be cramped. However, it is so important that submarine crews should be continuously kept on a high plane of efficiency that they are supplied with every conceivable comfort permitted by the natural limitations of submarine construction. Submarine boats so far have been used almost exclusively as instruments of warfare. One of their most important features, therefore, naturally is their armament. We have already heard something about the use of torpedoes by submarines. The early submarines had, as a rule, only one torpedo tube and were incapable of carrying more than 2 or 3 torpedoes. Gradually, however, both the number of torpedo tubes and of torpedoes was increased. The latest type have as many as 8 or 10 tubes and carry enough torpedoes to permit them to stay away from their base for several weeks. In recent years submarines have also been armed with guns. Naturally, these have to be of light weight and small caliber. They are usually mounted so that they can be used at a high angle. This is done in order to make it possible for submarines to defend themselves against attacks from airships. The mountings of these guns are constructed in such a way that the guns themselves disappear immediately after discharge and are not visible while not in use. Though mounted on deck, they are aimed and fired from below. As part of the armament of the submarine, we must also consider the additional protection which they receive from having certain essential parts protected by armor plate. All these features have increased the safety of submarine navigation to a great extent. In spite of the popular impression that submarine navigation entailed a greater number of danger factors than navigation on the surface of the water, this is not altogether so. If we stop to consider this subject, we can readily see why rather the opposite should be true. Navigation under the surface of the water greatly reduces the possibility of collision and also the dangers arising from rough weather, for the results of the latter are felt to a much lesser degree below than on the surface of the water. Many other factors are responsible for the comparatively high degree of safety inherent in submarines. Up to the outbreak of the present war, only about 250 lives had been lost as a result to accidents to modern submarines. Considering that up to 1910 a great deal of submarine navigation was more or less experimental, this is a record which can bear favorable comparison with similar records established by overwater navigation or by navigation in the air. To the average man the thought of imprisonment in a steel tube beneath the surface of the sea and being suddenly deprived of all means of bringing it up to air and light is a terrifying and nerve-shattering thing. It is probably the first consideration which suggests itself to one asked to make a submarine trip. Always the newspaper headlines dealing with a submarine disaster speak of those lost as drowned like rats in a trap. Men will admit that the progress of invention has greatly lessened the danger of accident to submarines, but nevertheless sturdily insist that when the accident does happen the men inside have no chance of escape. As a matter of fact, many devices have been applied to the modern submarine to meet exactly this contingency. Perhaps nothing is more effective than the so-called telephone buoy installed in our Navy and in some of those of Europe. This is a buoy lightly attached to the outer surface of the boat, containing a telephone transmitter and receiver connected by wire with a telephone within. In the event of an accident, this buoy is released and rises at once to the surface. A flag attached attracts the attention of any craft that may be in the neighborhood, and makes immediate communication with those below possible. Arrangements can then be made for raising the boat or towing her to some point at which salvage is possible. An instance of the value of this device was given by the disaster to the German submarine U-3, which was sunk at Kiel in 1910. Through the telephone the imprisoned crew notified those at the other end that they had oxygen enough for 48 hours, but that the work of rescue must be completed in that time. A powerful floating derrick grappled the sunken submarine and lifted its bow above water. 27 of the imprisoned crew crept out through the torpedo tubes. The captain and 2 lieutenants conceived it their duty to stay with the ship until she was actually saved. In the course of the operations one of the ventilators was broken, the water rushed in, and all 3 were drowned. In some of the Holland ships of late construction there is an ingenious, indeed an almost incredible device by which the ship takes charge of itself if the operators or crew are incapacitated. It has happened that the shock of a collision has so stunned the men cooped up in the narrow quarters of a submarine that they are for quite an appreciable time unable to attend to their duties. Such a collision would naturally cause the boat to leak and to sink. In these newer Holland ships an automatic device causes the ship, which she has sunk to a certain depth, registered of course by automatic machinery, to start certain apparatus which empties the ballast tanks and starts the pumps which will empty the interior of the ship if it has become flooded. The result is that after a few minutes of this automatic work, whether the crew has sufficiently recovered to take part in it or not, the boat will rise to the surface. This extraordinary invention is curiously reminiscent of the fact chronicled in earlier chapters of this book, that the most modern airplanes are so built that should the aviator become insensible or incapacitated for his work, if he will but drop the controls, the machine will adjust itself and make its own landing in safety. Unaided, the airplane drops lightly to earth. Unaided, the submarine rises buoyantly to the air. In recent years there have been developed special ships for the salvage of damaged or sunk submarines. At the same time the navies of the world have also produced special submarine tenders or mother ships. The purpose of these is to supply a base which can keep on the move with the same degree of facility which the submarine itself possesses. These tenders are equipped with air compressors, by means of which the air tanks of submarines can be refilled. Electric generators make it possible to replenish the submarine storage batteries. Mechanical equipment permits the execution of repairs to the submarine's machinery and equipment. Extra fuel, substitute parts for the machinery, spare torpedoes are carried by these tenders. The most modern of them are even supplied with dry dock facilities, powerful cranes, and sufficiently strong armament to repel attacks from boats of the type most frequently encountered by submarines. There are, of course, many other special appliances which make up the sum total of a modern submarine's equipment. Electricity is used for illuminating all parts of the boat. Heat is supplied in the same manner. This is a very essential feature, because the temperature of a submarine, after a certain period of submergence, becomes uncomfortably low. Electricity is also used for cooking purposes. Every submarine boat built to day is equipped with wireless apparatus. Naturally it is only of limited range, varying from 120 to 180 miles. But even at that it is possible for a submarine to send messages to its base or some other given point from a considerable distance by relay. If the submarine is running on the surface of the water, the usual means of naval communication, flag signals, wig-wagging, or the semaphore, can be employed. The submarine bell is another means for signaling. It is really a wireless telephone operating through the water instead of the air. Up to the present, however, it has not been sufficiently developed to permit its use for any great distance. It is so constructed that it can also be used as a sound detector. Some submarines, besides being equipped with torpedo tubes, carry other tubes for laying mines. In most instances this is only a secondary function of the submarine. There are, however, special mine-laying submarines. Others, especially of the lake type, have diving compartments which permit the employment of divers for the purpose of planting or taking up mines. Disappearing anchors, operated by electricity from within the boat, are carried. They are used for steadying the boat if it is desired to keep it for any length of time on the bottom of the sea in a current. From this necessarily brief description it can be seen readily that the modern submarine boat is a highly developed but very complicated mechanism. Naturally, it requires a highly trained, extremely efficient crew. The commanding officers must be men of strong personality, keen intellect, high mechanical efficiency, and quick judgment. The gradual increase in size has brought a corresponding increase in the number of a submarine's crew. A decade ago from 8 to 10 officers and men were sufficient, but today we hear of submarine crews that number anywhere from 25 to 40. In spite of the marvelous advances which have been made in the construction equipment and handling of the submarine during the last 10 years, perfection in many directions is still a long way off. How soon it will be reached, if ever, and by what means, are, of course, questions which only the future can answer. End of The Modern Submarine, Part 2. Recording by William Tomcho. Chapter 15 of Aircraft and Submarines by Willis J. Abbott. This LibriVox recording is in the public domain. Recording by William Tomcho. Aboard a submarine. Submarines have been compared to all kinds of things, from a fish to a cigar. Life on them has been described in terms of the highest elation as well as of the deepest depression. Their operation and navigation, according to some claims, require a veritable combination of mechanical, electrical, and naval genius, not only on the part of the officers, but even on that of the simplest oiler. While others make it appear as if a submarine was at least as simple to handle as a small motor boat, the truth concerning all these matters lies somewhere between these various extremes. It is quite true that except on the very latest submerged cruisers built by the Germans, the space for the men operating a submarine is painfully straitened. They must hold to their positions almost like a row of peas in a pod. From this results the gravest strain upon the nerves, so that it has been found in Germany that after a cruise a period of rest of equal duration is needed to restore the men to their normal condition. Before assignment to submarine duty, too, a special course of training is requisite. Submarine crews are not created in a day. What the interior of the new German submarines, with a length of 280 feet and a beam of 26 feet, may be, no man of the Anglo-Saxon race may know or tell. The few who have descended into these mysterious depths will have no chance to tell of them until the war is over. Nor is it possible during war times to secure descriptions even of our own underwater boats. But the interior of the typical submarine may be imagined as in size and shape something like an unusually long street car. Along the sides, where seats would normally be, are packed wheels, cylinders, motors, pumps, machinery of all imaginable kinds, and some of it utterly unimaginable to the lay observer. The whole interior is painted white and bathed in electric light. The casual visitor from above seas is dazed by the array of machinery and shrinks as he walks the narrow aisle lest he become entangled in it. Running on the surface, the submarine chamber is filled with a roar and clatter like a boiler shop in full operation. The Diesel engines are compact and powerful, but the racket they make more nearly corresponds to their power than to their size. On the surface, too, the boat rolls and pitches, and the stranger passenger, unequipped with sea legs, grabs for support as a subway rider reaches for a strap on the curves. But let the order come to submerge, the Diesels are stopped, the electric motors take up the task, spinning noiselessly in their jackets. In a moment or two all rolling ceases. One can hardly tell whether the ship is moving at all. It might, for all its motion tells, be resting quietly on the bottom. If you could disabuse your mind for a moment of the recollection that you were in a great steel cigar, heavy laden with explosives, and deep under the surface of the sea, you would find the experience no more exciting than a trip through the Pennsylvania tubes. But there is something uncanny about the silence. Go forward to the conical compartment at the very bow. There you will find the torpedo chamber for the submarine, like the cigar to which it is so often compared, carries its fire at its front tip. The most common type of boat will have 2 or 4 torpedo tubes in this chamber. The more modern ones will have a second torpedo chamber astern with the same number of tubes and carry other torpedoes on deck which by an ingenious device can be launched from their outside cradles by mechanism within the boat. In the torpedo chamber are twice as many spare torpedoes as there are tubes, made fast along the sides. Here, too, the anchor winch stands with the cable attached to the anchor outside the boat, and an automatic knife which cuts the cable should the anchor be fouled. Immediately aft of the torpedo chamber, cut off by a watertight partition, is the battery compartment. It gets its name because of the fact that beneath the deck, which is full of traps readily raised, are the electric storage batteries of anywhere from 60 to 260 cells according to the size of the boat. This room is commonly used as a loafing place for the crew, being regarded as very spacious and empty. In it are nothing but the electric stove, the kitchen sink, the various lockers for food, and all the housekeeping apparatus of the submarine. Mighty trim and compact they all are. The builder of 20th century flats with his kitchenettes and his indoor beds might learn a good deal from a study of the smaller type of submarine. Next aft comes the officers' staterooms, rather smaller than prison cells, each holding a bunk, a bureau, and a desk. Each holds also a good deal of moisture, for the greatest discomfort in submarine life comes from the fact that everything is dripping with the water resulting from the constant condensation of the air within. The great compartment amidships, given over to machinery, is a place to test the nerves. The aisle down the center is scarcely 2 feet wide, and on each side are whirling wheels, engines, and electric motors. Only the photographs can give a clear idea of the crowded appearance of this compartment. It contains steering wheels, the gyroscopic compass, huge valves, dials showing depth of submergence, Kingston levers, motor controllers, all polished and shining, each doing its work and each easily thrown out of gear by an ignorant touch. The author once spending the night on a United States man of war was shown by the captain to his own cabin, that officer occupying the admiral's cabin for the time. At the head of the bunk were 2 small electric push buttons, absolutely identical in appearance and about 2 inches apart. "Push this button," said the captain genially, "if you want the Jap boy to bring you shaving water or anything else. But be sure to push the right one. If you push the other, you will call the entire crew to quarters at whatever hour of night the bell may ring." The possibility of mistaking the button rested heavily on the writer's nerves all night. A somewhat similar feeling comes over one who walks the narrow path down the center of the machinery compartment of a submarine. He seems hedged about by mysterious apparatus, a touch of which, or even an accidental jostle, may release powerful and even murderous forces. While the submarine is under way, submerged, the operator in every piece of individual machinery stands at its side ready for action. Here are the gunner's mates at the diving rudder. They watch steadily a big gauge on which a needle which shows how deep the boat is sinking. When the required depth is reached, swift turns of 2 big brass wheels set the horizontal rudders that check the descent and keep the boat on an even keel. Other men stand at the levers of the Kingston valves which, when open, flood the ballast tanks with water and secure the submergence of the boat. Most of the underwater boats to day sink rapidly on an even keel. The old method of depressing the nose of the boat so as to make a literal dive has been abandoned, partly because of the inconvenience it caused to the men within who suddenly found the floor on which they were standing tilted at a sharp angle, and partly because the diving position proved to be a dangerous one for the boat. In the early days of the submarines the quarters for the men were almost intolerable. The sleeping accommodations were cramped, and there was no place for the men off duty to lounge and relax from the strain of constant attention to duty. Man cannot keep his body in a certain fixed position, even though it be not rigid, for many hours. This is shown as well at the baseball grounds at the end of the 6th inning, when all stretch, as it was in the old-time underwater boats. The crews now have space in which to loaf, and even the strain of long silent watches under water is relieved by the use of talking machines and musical instruments. The efficiency of the boat, of course, is only that of her crew, and since more care and more scientific thought has been given to the comfort of the men, to the purity of the air they breathe, and even to their amusements, the effect upon the work done by the craft has been apparent. 10 years ago hot meals were unthought of on a submarine. Now the electric cooker provides for quite an elaborate bill of fare. But 10 years ago the submarine was only expected to cruise for a few hours off the harbor's mouth, carrying a crew of 20 men or less. Now it stays at sea sometimes for as long as 3 months. Its crews number often as many as 50, and the day is in sight when accommodations will have to be made for the housing of at least 80 men in such comparative comfort that they can stand a 6 months' voyage without loss of morale or decrease in physical vigor. It is, of course, very rare that a civilian has a chance to be present on a submarine when the latter is making either a real or a feigned attack. Fred B. Pitney, a correspondent of the New York Tribune, was fortunate enough to have this experience, fortunate especially because it was all a game arranged for his special benefit by a French admiral. He writes of this interesting experience in the Tribune of Sunday, May 27, 1917, and at the same time gives a vivid description of a French submarine. It appears that Mr. Pitney was on a small vessel put at his disposal by the French Ministry of Marine to view the defenses of a French naval base. This boat was attacked by what seemed to be an enemy submarine, but later turned out to be a French one which was giving this special performance for Mr. Pitney's information. We read: "Our officers were experts at watching for submarines, and though the little white wave made by the periscope disappeared, they caught the white wake of the torpedo coming toward the port quarter and sheered off to escape it. The torpedo passed harmlessly by our stern. But the adventure was not ended, for hardly a minute later we heard a shot from off the starboard quarter, and, turning in that direction, saw that the submarine had come to the surface and was busily firing at us to bring us to. We stopped without any foolish waste of time in argument. I asked if a boat would be sent to us, or if we would have to get out our boat. 'They carry a small folding boat,' said the officer to whom I had been talking, 'but we will have to send our boat.' While we were getting our boat over the side, the submarine moved closer in, keeping her gun bearing on us all the time most uncomfortably. The gun stood uncovered on the deck, just abaft the turret. It was quickly coated with grease to protect it when the vessel submerged. It is only the very latest type of submarines that have disappearing guns which go under cover when the vessel submerges and are fired from within the ship, which makes all the more surprising the speed with which a submarine can come to the surface. The men get out on deck, fire the gun, get in again, and the vessel once more submerges. I was in the first boatload that went over to the submarine. From a distance it looked like nothing so much as a rather long piece of 4x8 floating on the water, with another block set on top of it and a length of lathe nailed on the block. It lost none of these characteristics as we neared it. It only gained a couple of ropes along the sides of the 4x8, while men kept coming mysteriously out of the block until a round dozen was waiting to receive us. The really surprising thing was that the men turned out to be perfectly good French sailors, with a most exceedingly polite French lieutenant to help us aboard the little craft. The vessel we were in was a 500-ton cruising submarine. It had just come from 8 months guarding the Channel, and showed all the battering of 8 months of a very rough and stormy career, with no time for a lie-up for repairs. It was interesting to see the commander hand the depth gauge a wallop to start it working and find out if the center of the boat was really 9 feet higher than either end. We were 54 feet under water and diving when the commander performed that little experiment, and we continued to dive while the gauge spun around and finally stopped at a place which indicated approximately that our back was not broken. I suppose that was one of the things my friend the lieutenant referred to when he said life on a submarine was such a sporting proposition. We boarded the submarine over the tail end and balanced our way up the long narrow block, like walking a tight rope, to the turret, where we descended through a hole like the opening into a gas main into a small round compartment about 6 feet in diameter, exactly in the midship section, which was the largest compartment in the ship. Running each way from it the length of the vessel were long corridors, some 2 feet wide. On each side of the corridors were rows of tiny compartments, which were the living and working rooms of the ship. Naturally, most of the space was given up to the working rooms. The officers' quarters consisted of 4 tiny compartments, 2 on each side of the after corridor. The first 2 were the mess room and chart room, and the second pair were the cabins of the commander, a lieutenant, and his second in command, an ensign. Behind them was an electric kitchen, and next came the engines. First, 2 sets of Diesel engines, 1 on each side of the corridor, each of 400 horsepower. These were for running on the surface. Then came 4 bunks for the quartermasters, and last the electric motors for running under the surface. The motors were run from storage batteries and were half the power of the Diesel engines. The quarters of the crew were along the sides of the forward corridor. The floors of the corridor were an unbroken series of trap doors covering the storage tanks for drinking water, food, and the ship's supplies. The torpedo tubes were forward of the men's quarters. 10 torpedoes were carried. The ammunition for the deck gun was stored immediately beneath the gun, which was mounted between the turret and the first hatch abaft the turret. Besides the turret there were 3 hatches in the deck, 1 forward and 2 aft. There were 34 men in the crew. The men were counted every 2 hours, as there is great danger of men being lost overboard when running on the surface, and in bad weather they are sometimes counted as often as every half hour. The turret was divided in 2 sections. In the after part was the main hatch, and behind it a stationary periscope, standing about 30 inches above the surface of the water when the deck was submerged, and only the periscope showing. There was no opening in the forward section of the turret, but the fighting periscope, which could be drawn down into the interior or pushed up to 10 feet above the surface when the vessel was completely submerged, extended through the top. For 2 hours, turn and turn about, the commander and his second stand watch on the iron grips in the turret, one eye on the periscope, the other on the compass. And this goes on for weeks on end. It is only when they lie for a few hours 50 to 75 feet below the surface that they can get some rest. And even then there is no real rest, for one or the other of them must be constantly on duty, testing pipes and gauges, air pressure, water pressure, and 1,000 other things. When we dropped through the hatch into the interior of the submarine and the cover was clamped down over our heads, the commander at once ordered me back into the turret. "Hurry, if you want to see her dive," he said. I climbed into the after section of the turret and fastened my eye to the periscope. Around the top of the turret was a circle of bull's eyes, and I was conscious of the water dashing against them while the spray washed over the glass of the periscope. The little vessel rolled very slightly on the surface, though there was quite a bit of sea running. I watched the horizon through the periscope and watched for the dive, expecting a distinct sensation, but the first thing I noticed was that even the slight roll had ceased, and I was surprised to see that the bull's eyes were completely under water. The next thing there was no more horizon. The periscope also was covered, and we were completely beneath the surface. "Did it make you sick?" the commander asked, when I climbed down from the turret, and when I told him no, he was surprised, for he said most men were made sick by their first dive. The thing most astonishing to me about that experience was how a submerged submarine can thread its way through a minefield. For though the water is luminous and translucent, one can hardly make out the black hull of the boat under the turret, and a mine would have to be on top of you before you could see it. The men who watch for mines must have a sense for them as well as particularly powerful sight. We continued to dive until we were 68 feet below the surface, too deep to strike any mine, and there we ran tranquilly on our electric engines, while the commander navigated the vessel and the second in command opened champagne in the 2x4 mess room. After half an hour of underwater work, we came near enough the surface for our fighting periscope to stick 20 inches out of the water and searched the lonely horizon for a ship to attack. It was not long before we sighted a mine trawler steaming for the harbor, and speeded up to overtake her. "Pikers," said our commander, as we circled twice around the trawler. "They can't find us." 5 men on the trawler were scanning the area with glasses looking for submarines. We could follow all their motions, could tell when they thought they had found us, and see their disappointment at their mistakes. But though we were never more than 500 yards from them, I did not think they were pikers because they did not find us. I had tried that hunt for the tiny wave of a periscope. "No use wasting a torpedo on those fellows," said our commander. "We will use the gun on them." "How far away can you use a torpedo?" I asked. "200 yards is the best distance," he said. "Never more than 500. A torpedo is pure guesswork at more than 500 yards." We crossed the bow of the trawler, circled around to her starboard quarter, and came to the surface, fired 9 shots, and submerged again in 45 seconds. The prey secured, we ran submerged through the mine field and passed a net barrier to come to the surface, well within the harbor, and proceed peacefully to our mooring under the shelter of the guns of the land forts. Life and work on a German submarine is known to us, of course, only from descriptions in German publications. One of these appeared previous to our entry in the war, in various journals, and was translated and republished by the New York Evening Post. It reads partly as follows: U-47 will take provisions and clear for sea. Extreme economical radius. A first lieutenant, with acting rank of commander, takes the order in the gray dawn of a February day. The hulk of an old corvette with the Iron Cross of 1870 on her stubby foremast is his quarters in port, and on the corvette's deck he is presently saluted by his first engineer and the officer of the watch. On the pier the crew of U-47 await him. At their feet the narrow gray submarine lies alongside, straining a little at her cables. "Well, we've got our orders at last," begins the commander, addressing his crew of 30, and the crew grin, for this is U-47's first experience of active service. She has done nothing save trial trips hitherto, and has just been overhauled for her first fighting cruise. Her commander snaps out a number of orders. Provisions are to be taken in up to the neck, fresh water is to be put aboard, and engine room supplies to be supplemented. A mere plank is the gangway to the little vessel. As the commander, followed by his officers, comes aboard, a sailor hands to each a ball of cotton waste, the sign and symbol of a submarine officer, which never leaves his hand. For the steel walls of the craft, the doors, and the companion ladder all sweat oil, and at every touch the hands must be wiped dry. The doorways are narrow round holes. Through one of the holes aft the commander descends by a breakneck iron ladder into the black hole lit by electric glow lamps. The air is heavy with the smell of oil, and to the unaccustomed longshoreman it is almost choking, though the hatches are off. The submarine man breathes this air as if it were the purest ozone. Here, in the engine room aft, men must live and strain every nerve, even if for days at a time every crack whereby the fresh air could get in is hermetically sealed. On their tense watchfulness 30 lives depend. Here, too, are slung some hammocks, and in them one watch tries, and, what is more, succeeds in sleeping, though the men moving about bump them with head and elbows at every turn, and the low and narrow vault is full of the hum and purr of machinery. In length the vault is about 10 feet, but if a man of normal stature stands in the middle and raises his arms to about half shoulder's height, his hands will touch the cold, moist steel walls on either side. A network of wires runs overhead, and there is a juggler's outfit of handles, levers, and instruments. The commander inspects everything minutely, then creeps through a hole into the central control station, where the chief engineer is at his post. With just about enough assistance to run a fairly simple machine ashore, the chief engineer of a submarine is expected to control, correct, and, if necessary, repair at sea an infinitely complex machinery which must not break down for an instant if 30 men are to return alive to the hulk. Forward is another narrow steel vault serving at once as engine room and crew's quarters. Next to it is a place like a cupboard, where the cook has just room to stand in front of his doll's house gallery stove. It is electrically heated, that the already oppressive air may not be further vitiated by smoke or fumes. A German submarine in any case smells perpetually of coffee and cabbage. 2 little cabins of the size of a decent clothes chest take the deck and engine room officers, 4 of them. Another box cabin is reserved for the commander, when he has time to occupy it. At daybreak the commander comes on deck in coat and trousers of black leather lined with wool, a protection against oil, cold, and sea water. The crew at their stations await the command to cast off. "Machines clear," calls a voice from the control station, and "Clear ship," snaps the order from the bridge. Then "Cast off." The cables slap on to the landing stage, the engines begin to purr, and U-47 slides away into open water. A few cable lengths away another submarine appears homeward bound. She is the U-20, returning from a long cruise in which she succeeded in sinking a ship bound with a cargo of frozen mutton for England. "Good luck, old sheep butcher," sings the commander of U-47 as the sister ship passes within hail. The seas are heavier now, and U-47 rolls unpleasantly as she makes the light ship and answers the last salute from a friendly hand. The two officers on the bridge turn once to look at the light ship already astern, then their eyes look seaward. It is rough, stormy weather. If the eggshell goes ahead 2 or 3 days without a stop, the officers in charge will get no sleep for just that long. If it gets any rougher, they will be tied to the bridge rails to avoid being swept overboard. If they are hungry, plates of soup will be brought to them on the bridge, and the North Sea will attend to its salting for them. Frequently this meal is interrupted by some announcement from the watch, such as "smoke on the horizon off the port bow." Then, so we are told, the commander drops his plate, shouts a short, crisp command, and an electric alarm whirs inside the eggshell. The ship buzzes like a hive. Then water begins to gurgle into the ballast tanks, and the U-47 sinks until only her periscope shows. "The steamship is a Dutchman, sir," calls the watch officer. The commander inspects her with the aid of a periscope. She has no wireless and is bound for the continent. So he can come up and is glad, because moving under the water consumes electricity, and the usefulness of a submarine is measured by her electric power. After 54 hours of waking nerve tension, sleep becomes a necessity. So the ballast tanks are filled and the nutshell sinks to the sandy bottom. This is the time for sleep aboard a submarine, because a sleeping man consumes less of the precious oxygen than one awake and busy. So a submarine man has 3 principal lessons to learn: to keep every faculty at tension when he is awake, to keep stern silence when he is ashore (there is a warning against talkativeness in all the German railway carriages now), and to sleep instantly when he gets a legitimate opportunity. His sleep and the economy of oxygen may save the ship. However, the commander allows half an hour's grace for music. There is a gramophone, of course, and the ship's band performs on all manner of instruments. At worst, a comb with a bit of tissue paper is pressed into service. Another American who suffered an enforced voyage on an Unterseeboot made public later some of his experiences. His captor's craft was a good-sized one, about 250 feet long, with a crew of 35 men and mounting 2 4½-inch guns. She could make 18 knots on the surface and 11 submerged, and had a radius of 3,200 miles of action. Her accommodations were not uncomfortable. Each officer had a separate cabin, while the crew were bunked along either side of a narrow passage. The ventilation was excellent, and her officers declared then they could stand 24 hours continuous submergence without discomfort. After that, for 6 hours it was uncomfortable, and thereafter intolerable because of the exudation of moisture, or sweating, from every part. At such times all below have to wear leather suits. The food was varied and cooked on an electric stove. The original stores included preserved pork and beef, vegetables, tinned soups, fruits, raisins, biscuits, butter, marmalade, milk, tea, and coffee. But the pleasures of the table depended greatly on the number of their prizes, for whenever possible they made every ship captured contribute heavily to their larder before sinking her. Of the tactics followed, the observer writes: "It appears that 55%, or more than half, of the torpedoes fired missed their mark, and with this average they seemed satisfied. Once they let go at a ship 2 torpedoes at 3,000 yards range, and both missed, the range being too long, but they did not care to come any nearer, as they believed the ship to be well armed. They prefer to fire at 500 to 700 yards, which means that at this range the track or wake of a projectile would be discernible for, say, 25 to 30 seconds, not much time, indeed, for any ship to get out of the way. At 100 yards range or less they do not care to fire unless compelled to, as the torpedo is nearly always discharged when the submarine is lying ahead of the object. i.e. to hit the ship coming up to it, it follows that a gun forward is more useful than one aft, the gun aft being of real service when a submarine starts shelling, which she will do for choice from aft the ship rather than from forward of her, where she would be in danger of being run over and rammed. End of Aboard a Submarine. Recording by William Tomcho. Chapter 16 of Aircraft and Submarines by Willis J. Abbott. This LibriVox recording is in the public domain. Recording by William Tomcho. Submarine Warfare, Part 1. At the moment of writing these words, the outcome of the greatest war the world has ever known is believed by many to hang upon the success with which the Allies can meet and defeat the campaign of the German submarines. The German people believe this absolutely. The Allies and their sympathizers grudgingly admit that they are only too fearful that it may be true. To such a marvelous degree of military efficiency has the ingenuity of man brought these boats which so recently as our Civil War were still in the vaguest experimental stage and scarcely possessed of any offensive power whatsoever. Nevertheless, these machines had reached a degree of development, and had demonstrated their dangerous character so early in the war that it was amazing that the British were so slow in comprehending the use that might be made of them in cutting off British commerce. It is true that the first submarine actions redounded in their results entirely to British credit. In September of 1914 a British submarine ran gallantly into Heligoland Bay, and sank the German light cruiser Hella at her moorings. Shortly after, the Germans sought retaliation by attacking a British squadron, but the effort miscarried. The British cruiser Birmingham caught a glimpse of her wake, and with a well-aimed shot destroyed her periscope. The submarine dived, but shortly afterwards came up again, making what was called a porpoise dive, which is to say she came up just long enough for the officer in the conning tower to locate the enemy, then submerged again. Brief, however, as had been the appearance of the conning tower, the British put a shell into it, and in a few minutes the submarine and most of her crew were at the bottom of the sea. Soon after followed the attack upon and sinking of the three cruisers by the submarine under the command of Lieutenant Commander Otto von Weddigen, the narrative of which we have already told. But while after that attacks upon British armed ships were many, successes were few. There were no German ships at sea for the British to attack in turn, but some very gallant work was done by their submarines against Austrian and Turkish warships in the Mediterranean and the Dardanelles. All this time the Germans were preparing for that warfare upon the merchant shipping of all countries which at the end they came to believe would force the conclusion of the war. It seems curious that during this early period the Allies were able to devise no method of meeting this form of attack. When the United States entered the war, more than 3 years later, they looked to us for the instant invention of some effective anti-submarine weapon. If they were disappointed at our failure at once to produce one, they should have remembered at least that they too were baffled by the situation, although it was presented to them long before it became part of our problems. About no feature of the war have the belligerents thrown more of mystery than about the circumstances attending submarine attacks upon battleships and armed transports and the method employed of meeting them. Even when later in the war the Germans, apparently driven to frenzy, made special efforts to sink hospital and Red Cross ships, the facts were concealed by the censors, and accounts of the efforts made to balk such inhuman and unchristian practices diligently suppressed. In the end it seemed that the British, who of course led all naval activities, had reached the conclusion that only by the maintenance of an enormous fleet of patrol boats could the submarines be kept in check. This method they have applied unremittingly. Alfred Noyes, in a publication authorized by the British government, has thus picturesquely told some of the incidents connected with this service. It is difficult to convey in words the wide sweep and subtle coordination of this ocean hunting, for the beginning of any tale may be known only to an admiral in a London office, the middle of it only to a commander at Kirkwall, and the end of it only to a trawler skipper off the coast of Ireland. But here and there it is possible to piece the fragments together into a complete adventure, as in the following record of a successful chase, where the glorious facts outrun all the imaginations of the wildest melodrama. There were suspicious vehicles at anchor, one moonless night, in a small bay near the Mumbles. They lay there like shadows, but before long they knew that the night was alive for 100 miles with silent talk about them. At dawn His Majesty's trawlers, Golden Feather and Peggy Newton, foamed up, but the shadows had disappeared. The trawlers were ordered to search the coast thoroughly for any submarine stores that might have been left there. Thoroughly in this war means a great deal. It means that even the bottom of the sea must be searched. This was done by grapnels, but the bottom was rocky and seemed unfit for a base. Nothing was found but a battered old lobster pot crammed with seaweed and little green crabs. Probably these appearances were more than usually deceitful, for shortly afterward watchers on the coast reported a strange fishing boat, with patched brown sails, heading for the suspected bay. Before the patrols came up, however, she seemed to be alarmed. The brown sails were suddenly taken in, the disguised conning tower was revealed, and this innocent fishing boat, gracefully submerging, left only the smiling and spotless April seas to the bewildered eyes of the Coast Guard. In the meantime signals were pulsing and flashing on land and sea, and the U-boat had hardly dipped when, over the smooth green swell, a great Sea Hawk came whirring up to join the hunt, a hawk with light yellow wings and a body of service gray, the latest type of seaplane. It was one of those oily seas in which a watcher from the air may follow a submarine for miles, as an olive green shadow under the lighter green. The U-boat doubled twice, but it was half an hour before her sunken shadow was lost to sight under choppy blue waters, and long before that time she was evidently at ease in her mind and pursuing a steady course. For the moment her trail was then lost, and the Hawk, having reported her course, dropped out of the tail. The next morning, in the direction indicated by that report, several patrol boats heard the sound of gunfire and overhauled a steamer which had been attacked by a submarine. They gave chase by starring to all the points of the compass, but could not locate the enemy. A little later, however, another trawler observed the wash of a submarine crossing her stern about 200 yards away. The trawler starboarded, got into the wake of the submarine, and tried to ram her at full speed. She failed to do this, as the U-boat was at too great a depth. The enemy disappeared, and again the trawlers gathered and starred. In the meantime certain nets had been shot, and though the enclosed waters were very wide, it was quite certain that the submarine was contained within them. Some hours later another trawler heard firing and rushed toward the sound. About sunset she sighted a submarine which was just dipping. The trawler opened fire at once without result. The light was very bad, and it was very difficult to trace the enemy, but the trawler continued the search, and about midnight she observed a small light close to the water. She steamed within a few yards of it and hailed, thinking it was a small boat. There was a considerable amount of wreckage about, which was afterward proved to be the remains of a patrol vessel sunk by the submarine. There was no reply to the hail, and the light instantly disappeared. For the third time the patrols gathered and starred from this new point. And here the tale was taken up by a sailor who was in command of another trawler at the time. I give it, so far as possible, in his own words. About 4 o'clock in the morning I was called by deckhand William Brown to come on deck and see if an object sighted was a submarine. I did so, and saw a submarine about a mile distant on the port bow. I gave the order, "Hard a starboard." The ship was turned until the gun was able to bear on the submarine, and it was kept bearing. At the same time I ordered hands to station, and about 10 minutes afterward I gave the order to fire. The submarine immediately altered her course from west to north-northwest and went away from us very fast. I burned lights to attract the attention of the drifters, and we followed at our utmost speed, making about 8 knots and shipping light sprays. We fired another shot about 2 minutes later, but it was breaking dawn, and we were unable to see the fall of the shots. After the second shot the submarine submerged. I hoisted warning signals, and about half an hour later I saw a large steamer turning around, distant between 2 and 3 miles on our starboard beam. I headed toward her, keeping the gun trained on her, as I expected, judging by her action, that she had smelt the submarine. When we were about a mile and a half from the steamer, I saw the submarine half a mile astern of her. We opened fire again and gave her 4 shots, and about 2 minutes between 'em. The submarine then dodged behind the off quarter of the steamer." He paused to light his pipe and added quite gravely, "When she had disappeared behind the steamer, I gave the order 'Cease fire,' to avoid hitting the larger vessel." I made a mental note of his thoughtfulness, but not for worlds would I have shown any doubt of his power to blast his way, if necessary, through all the wood and iron in the universe, and I was glad that the blue clouds of our smoke mingled for a moment between us. "I saw 2 white boats off the port quarter," he continued, "but I paid no attention to them. I ordered the helm to be starboarded a bit more, and told the gunner to train his gun on the bow of the steamer, for I expected the submarine to show there next. A few minutes later she did so, and when she drew ahead I gave the order to fire. I should say we were about 1.25 miles away. We gave him 2 more shots, and they dropped very close, as the spray rose over his conning tower. He altered his course directly away from us, and we continued to fire. The 3rd shot smothered his conning tower with spray. I did not see the 4th and 5th shots pitch. There was no splash visible, although it was then broad daylight, so I believed they must have hit him. A few moments after this the submarine disappeared." I turned, then, toward the 2 white boats and hailed them. The chief officer of the steamer was in charge of one. They were returning to their ship, and told me that we had hit the submarine. We escorted them through the nets and parted very good friends. "How did you get the scalp of this U boat?" I asked. "We signaled to the admiral and sent the Daffy to investigate. She found the place, all right. It was a choppy sea, but there was one smooth patch in it, just where we told him the submarine had disappeared. A big patch of water like wavy satin, 200 or 300 yards of it, colored like the stripes on a mackerel, all blue and green with oil. They took a specimen of the oil." "Did it satisfy the Admiralty?" "No, nothing satisfies the Admiralty but certainties. They count the minimum losses of the enemy and the maximum of their own. Very proper, too. Then you know where you are, but mind you, I don't believe we finished him off that morning. Oil don't prove that. It only proves we hit him." "I believe it was the Maggie and Rose that killed him, or the Hawthorne. No, it wasn't either. It was the Loch Awe." "How was that?" "Well, as Commander White was telling you, we shot out nets to the north and south of him. There were 200 or 300 miles, perhaps, in which he might wriggle about, but he couldn't get out of the trap, even if he knew where to look for the danger. He tried to run for home, and that's what finished him." "They'll tell you all about that on the Loch Awe." So the next day I heard the end of the yarn from a sandy-haired skipper in a trawler whose old romantic name was dark with new significance. He was terribly logical. In his cabin, a comfortable room with a fine big stove, he had a picture of his wife and daughters, all very rigid and uncomfortable. He also had 3 books. They included neither Burns nor Scott. One was the Bible, thumbed by his grandfather and his father till the paper had worn yellow and thin at the sides. The second, I am sorry to say, was called The Beautiful White Devil. The third was an odd volume of Froude in the Everyman edition. It dealt with the Armada. "I was towing my nets with the rest of my group," he said, "till about 3 o'clock in the mornin' on yon occasion. It was fine weather with a kind of har. All at once my ship gaed 6 points off her course, frae southeast to east northeast, and I jaloused that the nets had been fouled by some muckle moving body. I gave orders to pit the wheel hard a port, but she would na answer. Suddenly the strain on the nets stoppit. I need not tell you what had happened, of course. It was preceesely what the Admiralty had arranged that happened when gentlemen in undersea boats try to cut their way through our nets. Mind ye, the nets are verra expensive." A different situation, however, was lately developed in the more unequal fight between submarines and merchant vessels. There the submarine unquestionably was gained and maintained supremacy. Two factors are primarily responsible for this: lack of speed and lack of armament on the part of the merchantman. Of course, recently the latter condition has been changed and apparently with good success. But even at best an armed merchantman has a rather slim chance at escape. Neither space nor available equipment permits a general arming of merchantmen to a sufficient degree to make it possible for the latter to attack a submarine from any considerable distance. Then, too, what chance has a merchant vessel unprotected by patrol boats to escape the torpedo of a hidden submarine? How successfully this question will finally be solved, the future only will show. At present it bids fair to become one of the deciding factors in determining the final issue of this war. The first authentically known case of an attack without warning by a German submarine against an Allied merchantman was the torpedoing of the French steamship Admiral Jetom on October 26, 1914, in the English Channel. The steamer was sunk and 30 of its passengers and crew were lost. A number of other attacks followed during the remainder of 1914 and in January 1915. Then came on February 3, 1915, the now famous pronouncement of the German government declaring all the waters around Great Britain and Ireland, including the whole of the English Channel, a war zone, and announcing that on and after February 18th Germany will attempt to destroy every enemy ship found in that war zone, without its being always possible to avoid the danger that will thus threaten neutral persons and ships. Germany gave warning that it cannot be responsible hereafter for the safety of crews, passengers, and cargoes of such ships, and it furthermore calls the attention of neutrals to the fact that it would be well for their ships to avoid entering this zone, for although the German naval forces are instructed to avoid all violence to neutral ships, insofar as these can be recognized, the order given by the British government to hoist neutral flags and the contingencies of naval warfare might be the cause of these ships becoming the victims of an attack directed against the vessels of the enemy. This was the beginning of the submarine controversy between Germany and the United States, and resulted in a note from the United States government in which it was stated that the latter viewed the possibilities created by the German note with such grave concern that it feels it to be its privilege, and indeed its duty in the circumstances, to request the Imperial German Government to consider before action is taken the critical situation in respect to the relation between this country and Germany which might arise were the German naval forces, in carrying out the policy foreshadowed in the Admiralty's proclamation, to destroy any merchant vessel of the United States or cause the death of American citizens, to declare and exercise a right to attack and destroy any vessel entering a prescribed area of the high seas without first certainly determining its belligerent nationality and the contraband character of its cargo, would be an act so unprecedented in naval warfare that this government is reluctant to believe that the Imperial Government of Germany in this case contemplates it as possible. After stating that the destruction of American ships or American lives on the high seas would be difficult to reconcile with the friendly relations existing between the two governments, the note adds that the United States would be constrained to hold the Imperial Government of Germany to a strict accountability for such acts of their naval authorities, and to take any steps it might feel necessary to take to safeguard American lives and property and to secure to American citizens the full enjoyment of their acknowledged rights on the high seas. End of Submarine Warfare, Part 1. Recording by William Tomcho. Chapter 16 of Aircraft and Submarines by Willis J. Abbott. This LibriVox recording is in the public domain. Recording by William Tomcho. Submarine Warfare, Part 2. It is not within the province of this book to go in detail into the diplomatic history of the submarine controversy between Germany and the United States. Suffice it to say, therefore, that from the very beginning the controversy held many possibilities of the disastrous ending which finally came to pass when diplomatic relations were broken off between the two countries on February 3, 1917, and a state of war was declared by President Wilson's proclamation of April 6, 1917. The period between Germany's first war zone declaration and the President's proclamation, 2 months and 3 days more than 2 years, was crowded with incidents in which submarines and submarine warfare held the center of the stage. It would be impossible within the compass of this story to give a complete survey of all the boats that were sunk and of all the lives that were lost. Nor would it be possible to recount all the deeds of heroism which this new warfare occasioned. Belligerents and neutrals alike were affected. American ships suffered, perhaps to a lesser degree than those of other neutrals, partly because of the determined stand taken by the United States Government. On May 1, 1915, the first American steamer, the Gulf Flight, was sunk. 6 days later the world was shocked by the news that the Lusitania, one of the biggest British passenger liners, had been torpedoed without warning on May 7, 1915, and had been sunk, with a loss of 1,198 lives, of whom 124 were American citizens. Before this nation was goaded into war, more than 200 Americans were slain. Notes were again exchanged between the two governments. Though the German government at that time showed an inclination to abandon its position in the submarine controversy under certain conditions, sinkings of passenger and freight steamers without warning continued. All attempts on the part of the United States Government to come to an equitable understanding with Germany failed on account of the latter's refusal to give up submarine warfare, or at least those features of it which, though considered illegal and inhuman by the United States, seemed to be considered most essential by Germany. Then came the German note of January 31, 1917, stating that from February 1, 1917, sea traffic will be stopped with every available weapon and without further notice, in certain minutely described prohibited zones around Great Britain, France, Italy, and in the eastern Mediterranean. The total tonnage sunk by German submarines from the beginning of the war up to February 1, 1917, has been given by British sources as over 3 million tons, while German authorities claimed 4 million. The result of the German edict for unrestricted submarine warfare has been rather appalling, even if it fell far short of German prophecies and hopes. During the first 2 weeks of February, a total of 97 ships with a tonnage of about 210,000 tons were sent to the bottom of the sea. Since then, the German submarines have taken an even heavier toll. It has, however, become next to impossible, due to the restrictions of censorship, to compute any accurate figures for later totals, though it has become known from time to time that the Allied as well as the neutral losses have been very much higher during the 5 months of February to July 1917 than during any other 5 months. The figures of the losses of British merchantmen alone are shown by the following table. Note: the table has been edited, omitting over 1,600 tons and under 1,600 tons designations, and giving the totals. Week ending March 4th, 23 tons. March 11th, 17 tons. March 18th, 24 tons. March 25th, 25 tons. April 1st, 31 tons. April 8th, 19 tons. April 15th, 28 tons. April 22nd, 55 tons. April 29th, 51 tons. May 6th, 46 tons. May 13th, 23 tons. May 20th, 27 tons. May 27th, 19 tons. June 3rd, 18 tons. June 10th, 32 tons. June 17th, 32 tons. June 24th, 28 tons. July 1st, 20 tons. July 8th, 17 tons. July 15th, 18 tons. July 22nd, 24 tons. July 29th, 21 tons. August 5th, 23 tons. August 12th, 16 tons. August 19th, 18 tons, August 26th, 23 tons, September 2nd, 23 tons, September 9th, 18 tons, September 16th, 15 tons, September 30th, 13 tons, October 7th, 16 tons, October 14th, 18 tons, October 21st, 25 tons, October 28th, 18 tons, November 4th, 12 tons, November 11th, 6 tons. The table, with its week-by-week report of the British losses, is of importance because at the time it was taken as a barometer indicative of German success or failure. The German Admiralty at the moment of declaring the ruthless submarine war promised the people of Germany that they would sink 1,000,000 tons a month, and by so doing would force England to abject surrender in the face of starvation within 3 months. During that period the whole civilized world looked eagerly for the weekly statement of British losses. Only at one time was the German estimate of 1,000,000 tons monthly obtained. Most of the time the execution done by the undersea boats amounted to less than half that figure. So far from England being beaten in 3 months, at the end of 10 she was still unshattered, though sorely disturbed by the loss of so much shipping. Her new crops had come on, and her statesmen declared that so far as the food supply was concerned, they were safe for another year. During this period of submarine activity, the United States entered upon the war, and its government immediately turned its attention to meeting the submarine menace. In the first 4 months literally nothing was accomplished toward this end. A few submarines were reported sunk by merchantmen, but in nearly every instance it was doubtful whether they were actually destroyed or merely submerged purposely in the face of a hostile fire. Americans were looked upon universally as a people of extraordinary inventive genius, and everywhere it was believed that by some sudden lucky thought an American would emerge from a laboratory equipped with a sovereign remedy for the submarine evil. Prominent inventors indeed declared their purpose of undertaking this search, and went into retirement to study the problem. From that seclusion none had emerged with a solution at the end of 10 months. When the submarine campaign was at its very height, no one was able to suggest a better remedy for it than the building of cargo ships in such quantities that, sink as many as they might, the Germans would have to let enough slip through to sufficiently supply England with food and with the necessary munitions of war. Many cruel sufferings befell seafaring people during the period of German ruthlessness on the high seas. An open boat, overcrowded with refugees, hastily provisioned as the ship to which it belonged was careening to its fate, and tossing on the open sea 200 or 300 miles from shore in the icy nights of midwinter, was no place of safety or of comfort. Yet the Germans so construed it, holding that when they gave passengers and crew of a ship time to take to the boats, they had fully complied with the international law providing that in the event of sinking a ship its people must first be given an opportunity to assure their safety. There have been many harrowing stories of the experiences of survivors thus turned adrift. Under the auspices of the British government, Rudyard Kipling wrote a book detailing the agonies which the practice inflicted upon helpless human beings, including many women and children. Some of the survivors have told in graphic story the record of their actual experiences. Among these, one of the most vivid is from the pen of a well-known American journalist, Floyd P. Gibbons, correspondent of the Chicago Tribune. He was saved from the British liner Laconia, sunk by a German submarine, and thus tells the tale of his sufferings and final rescue. I have serious doubts whether this is a real story. I am not entirely certain that it is not all a dream, and that in a few minutes I will wake up back in stateroom B-19 on the promenade deck of the Cunarder Laconia and hear my Cockney steward informing me of an abundance of "and sirs" that it is a fine morning. I am writing this within 30 minutes after stepping on the dock here in Queenstown from the British minesweeper which picked up our open lifeboat after an eventful 6 hours of drifting, and darkness and bailing and pulling on the oars and of straining aching eyes toward that empty, meaningless horizon in search of help. But dream or fact, here it is. The first cabin passengers were gathered in the lounge Sunday evening, with the exception of the bridge fiends in the smoking room. Poor Butterfly was dying wearily on the talking machine, and several couples were dancing. About the tables in the smoke room the conversation was limited to the announcement of bids and orders to the stewards. This group had about exhausted available discussion when the ship gave a sudden lurch sideways and forward. There was a muffled noise like the slamming of some large door at a good distance away. The slightness of the shock and the mildness of the report, compared with my imagination, was disappointing. Every man in the room was on his feet in an instant. I looked at my watch. It was 10:30. Then came 5 blasts on the whistle. We rushed down the corridor leading from the smoking room at the stern to the lounge, which was amidships. We were running, but there was no panic. The occupants of the lounge were just leaving by the forward doors as we entered. It was dark when we reached the lower deck. I rushed into my stateroom, grabbed life preservers and overcoat, and made my way to the upper deck on that same dark landing. I saw the chief steward opening an electric switch box in the wall and turning on the switch. Instantly the boat decks were illuminated. That illumination saved lives. The torpedo had hit us well astern on the starboard side and had missed the engines and the dynamos. I had not noticed the deck lights before. Throughout the voyage over decks had remained dark at night, and all cabin portholes were clamped down and all windows covered with opaque paint. The illumination of the upper deck on which I stood made the darkness of the water, 60 feet below, appear all the blacker when I peered over the edge at my station boat, No. 10. Already the boat was loading up, and men and boys were busy with the ropes. I started to help near a davit that seemed to be giving trouble, but was stoutly ordered to get out of the way and get into the boat. We were on the port side, practically opposite the engine well. Up and down the deck, passengers and crew were donning life belts, throwing on overcoats, and taking positions in the boats. There were a number of women, but only one appeared hysterical. The boat started downward with a jerk toward the seemingly hungry rising and falling swells. Then we stopped and remained suspended in mid-air, while the men at the bow and the stern swore and tussled with the lowering ropes. The stern of the boat was down, the bow up, leaving us at an angle of about 45 degrees. We clung to the seats to save ourselves from falling out. "Who's got a knife? A knife! A knife!" bawled a sweating seaman in the bow. "Great God, give him a knife!" bawled a half-dressed, gibbering negro stoker who wrung his hands in the stern. A hatchet was thrust into my hand, and I forwarded it to the bow. There was a flash of sparks as it crashed down on the holding pulley. Many feet and hands pushed the boat from the side of the ship, and we sagged down again, this time smacking squarely on the billowy top of a rising swell. As we pulled away from the side of the ship, its receding terrace of lights stretched upward. The ship was slowly turning over. We were opposite that part occupied by the engine rooms. There was a tangle of oars, spars, and rigging on the seat, and considerable confusion before 4 of the big sweeps could be manned on either side of the boat. The gibbering, bullet-headed negro was pulling directly behind me, and I turned to quiet him as his frantic reaches with his oar were hitting me in the back. "Get away from her! Get away from her!" he kept repeating. "When the waters hits her hot boilers she'll blow up, and there's just tons and tons of shrapnel in the hold." His excitement spread to other members of the crew in the boat. It was the give way of nerve tension. It was bedlam and nightmare. We rested on our oars, with all eyes on the still-lighted Laconia. The torpedo had struck at 10:30 p.m. It was 30 minutes afterward that another dull thud, which was accompanied by a noticeable drop in the hulk, told its story of the second torpedo that the submarine had dispatched through the engine room and the boat's vitals from a distance of 200 yards. We watched silently during the next minute as the tiers of lights dimmed slowly from white to yellow, then a red, and nothing was left but the murky morning of the night, which hung over all like a pall. A mean, cheese-colored crescent of a moon revealed one horn about a ragged bundle of clouds low in the distance. A rim of blackness settled around our little world, relieved only by general leering stars in the zenith, and where the Laconia's lights had shone, there remained only the dim outlines of a blacker hulk standing out above the water like a jagged headland, silhouetted against the overcast sky. The ship sank rapidly at the stern until at last its nose stood straight in the air. Then it slid silently down and out of sight like a piece of disappearing scenery in a panorama spectacle. Boat No. 3 stood closest to the ship, and rocked about in a perilous sea of clashing spars and wreckage. As our boat's crew steadied its head into the wind, a black hulk, glistening wet and standing about 8 feet above the surface of the water, approached slowly and came to a stop opposite the boat and not 6 feet from the side of it. "What ship was dot?" The correct words in throaty English, with a German accent, came from the dark hulk, according to Chief Steward Balin's statement to me later. "The Laconia," Balin answered. "What?" "The Laconia, Cunard Line," responded the steward. "What did she weigh?" was the next question from the submarine. 18,000 tons." "Any passengers?" 73, replied Balia. "Men, women, and children, some of them in this boat. She had over 200 in the crew." "Did she carry cargo?" "Yes." "Well, you'll be all right. The patrol will pick you up soon." And without further sound, save for the almost silent fixing of the conning tower lid, the submarine moved off. There was no assurance of an early pickup, even though the promise were from a German source, for the rest of the boats, whose occupants, if they felt and spoke like those in my boat, were more than mildly anxious about their plight and the prospects of rescue. The fear of some of the boats crashing together produced a general inclination toward further separation on the part of all the little units of survivors, with the result that soon the small craft stretched out for several miles, all of them endeavoring to keep their heads in the wind. And then we saw the first light, the first sign of help coming, the first searching glow of white brilliance, deep down on the somber sides of the black pot of night that hung over us. It was way over there, first a trembling quiver of silver against the blackness, then, drawing closer, it defined itself as a beckoning finger, although still too far away yet to see our feeble efforts to attract it. We pulled, lustily forgetting the strain and pain of innards torn and racked from pain, vomiting, oblivious of blistered hands and wet, half-frozen feet. Then a nodding of that finger of light, a happy, snapping, crap-shooting finger that seemed to say, "Come on, you men," like a dice player wooing the bones, led us to believe that our lights had been seen. This was a fact, for immediately the coming vessel flashed on its green and red side lights, and we saw it was headed for our position. "Come alongside port," was megaphoned to us, and as fast as we could we swung under the stern while a dozen flashlights blinked down to us and orders began to flow fast and thick. A score of hands reached out, and we were suspended in the husky, tattooed arms of those doughty British Jack tars, looking up into the weather-beaten, youthful faces, mumbling thanks and thankfulness, and reading in the gold lettering on their pancake hats the legend, "H.M.S. Laburnum." Of course, the submarine fleets of the various navies paid a heavy toll, too. It has become, however, increasingly difficult to get any accurate figures of these losses. The British Navy, it is known, has lost during 1914, 1915, and 1916 12 boats, some of which foundered, were wrecked or mined, while others simply never returned. The loss of 8 German submarines has also been definitely established. Others, however, are known to have been lost, and their number has been greatly increased since the arming of merchantmen. In 1917 it was estimated that the Germans lost 1 U-boat a week and built 3. Just what sensations a man experiences in a submerged submarine that finds it impossible to rise again is, of course, more or less of a mystery. For those submarines, the entire crew of which perished, have been raised later, only one record has ever been known to have been made covering the period during which death by suffocation or drowning stared their occupants in the face. This heroic and pathetic record was written in form of a letter by the commander of a Japanese submarine, Lieutenant Takuma Faotomu, whose boat, with its entire crew, was lost on April 15, 1910, during manoeuvres in Hiroshima Bay. The letter reads in part as follows: "Although there is, indeed, no excuse to make for the sinking of His Imperial Majesty's boat, and for the doing away of subordinates through my heedlessness, all on the boat have discharged their duties well, and in everything acted calmly until death. Although we are departing in pursuance of our duty to the state, the only regret we have is due to anxiety lest the men of the world may misunderstand the matter, and that thereby a blow may be given to the future development of submarines. While going through gasoline submarine exercise, we submerged too far, and when we attempted to shut the sluice valve, the chain in the meantime gave way. Then we tried to close the sluice valve by hand, and it was too late, the rear part being full of water, and the boat sank at an angle of about 25 degrees. The switchboard being under water, the electric lights gave out, offensive gas developed, and respiration became difficult. The above has been written under the light of the conning tower when it was 11:45 o'clock. We are now soaked by the water that has made its way in. Our clothes are very wet, and we feel cold. I have always expected death whenever I left my home, and therefore my will is already in the drawer at Karasaki. I beg respectfully to say to His Majesty that I respectfully request that none of the families left by my subordinates shall suffer. The only matter I am anxious about now is this: atmospheric pressure is increasing, and I feel as if my tympanum were breaking. At 12:30 o'clock respiration is extraordinarily difficult. I am breathing gasoline. I am intoxicated with gasoline. It is 12:40 o'clock." Could there be a more touching record of the way in which a brave man met death? End of Submarine Warfare, Part 2. Recording by William Tomcho. Chapter 16 of Aircraft and Submarines by Willis J. Abbott. This LibriVox recording is in the public domain. Recording by William Tomcho. Submarine Warfare, Part 3. More interest in submarine warfare than ever before was aroused in this country when the German war submarine U-53 unexpectedly made its appearance in the harbor of Newport, Rhode Island, during the afternoon of October 7, 1916. About 3 hours afterwards, without having taken on any supplies, and after explaining her presence by the desire of delivering a letter addressed to Count von Bernstorff, then German ambassador at Washington, the U-53 left as suddenly and mysteriously as she had appeared. This was the first appearance of a foreign war submarine in an American port. It was claimed that the U-53 had made the trip from Wilhelmshaven in 17 days. She was 213 feet long, equipped with 2 guns, 4 torpedo tubes, and an exceptionally strong wireless outfit. Besides her commander, Captain Rose, she was manned by 3 officers and 33 men. Early the next morning, October 8th, it became evident what had brought the U-53 to this side of the Atlantic. At the break of day she made her reappearance southeast of Nantucket. The American steamer Canson, of the American Hawaiian Company, bound from New York by way of Boston to Genoa, was stopped by her, but after proving her nationality and neutral ownership, was allowed to proceed. 5 other steamships, 3 of them British, 1 Dutch, and 1 Norwegian, were less fortunate. The British freighter Strathhand, of 4,321 tons, was the first victim. Her crew were taken aboard the Nantucket Shoals light ship. 2 other British freighters, West Point and Stefano, followed in short order to the bottom of the ocean. The crews of both were saved by United States torpedo boat destroyers who had come from Newport as soon as news of the U-53's activities had been received there. This was also the case when the crews of the Dutch Bloemersdik and the Norwegian tanker Christian Knutsen. Not often in recent years has there been put on American naval officers quite so disagreeable a restraint as duty enforced upon the commander of the destroyers who watched the destruction of these friendly ships, almost within our own territorial waters, by an arrogant foreigner who gave himself no concern over the rescue of the crews of the sunken ships, but seemed to think that the function of the American men of war. It was no secret at the time that sentiment in the Navy was strongly pro-Ally. Probably, had it been wholly neutral, the mind of any commander would have revolted at the spectacle of wanton destruction of property and callous indifference to human life. It is quite probable that had this event occurred before the invention of wireless telegraphy had robbed the Navy commander at sea of all initiative, there might have happened off Nantucket something analogous to the famous action of Commodore Tatnall when, with the cry, "Blood is thicker than water," he took a part of his crew to the aid of British vessels sorely pressed by the fire of certain Chinese forts on the Yellow River. As it is an open secret that one commander appealed by wireless to Washington for authority to intervene. He did not get it, of course. No possible construction of international law would give us rights beyond the 3-mile limit. He had at least, however, the satisfaction, when the German commander asked him to move his ship to a point at which it would not interfere with the submarine's fire upon one of the doomed vessels, of telling him to move his own ship, and accompanying the suggestion with certain phrases of elaboration thoroughly American. The rapid development of submarine warfare naturally made it necessary to find ways and means to combat this new weapon of naval warfare. Much difficulty was experienced, especially in the beginning, because there were no precedents, and because for a considerable period everything that was tried had necessarily to be of an experimental nature. To protect harbors and bays was found comparatively easy. Nets were spread across their entrances. They were made of strong wire cables, and to judge from the total absence of submarines within the harbors thus guarded, they proved a successful deterrent. In most cases they were supported by extensive mine fields. The danger of these to submarines, however, is rather a matter of doubt, for submarines can dive successfully under them and by careful navigating escape unharmed. The general idea of fighting submarines with nets was also adopted for areas of open water which were suspected of being infested with submarines. Recently serious doubts have been raised concerning the future usefulness of nets. Reports have been published that German submarines have been fitted up with a wire and cable cutting appliance which would make it possible for them to break through nets at will, supposing, of course, that they had been caught by the nets in such a way that no vital parts of the underwater craft had been seriously damaged. A sketch of this wire cutting device was made by the captain of a merchantman who, while in a small boat after his ship had been torpedoed, had come close enough to the attacking submarine to make the necessary observations. The sketch showed an arrangement consisting of a number of strands of heavy steel hawsers which were stretched from bow to stern, passing through the conning tower, and to which were attached a series of heavy circular knives a foot in diameter and placed about a yard apart. Even as early as January 1915, Mr. Simon Lake, the famous American submarine engineer and inventor, published an article in the Scientific American in which he dwelt at length on means by which a submarine could escape mines and nets. One of the illustrations accompanying this article showed a device enabling submarines traveling on the bottom of the sea to lift a net with a pair of projecting arms and thus pass unharmed under it. Many other devices to trap, sink, or capture submarines have been invented. A large number of these, of course, have been found impracticable. Others, however, have been used with success. Few details of any of these have been allowed to become known. The most dangerous power of submarines is their ability to approach very closely to their object of attack without making their presence known to their prey. This naturally suggested that a way be found to detect the presence of submarines early enough to make it possible to stave off an attack or even to assume the offensive against the underwater boat. A recent invention, the perfection of which is due to the work of Mr. William Dubilier, an American electrical engineer, and of Professor Tissot, a member of the French Academy of Science, is the microphone. few details are known about this instrument except that it records sound waves at as great a distance as 55 miles. This would permit in most cases the calling of patrol boats or the use of other defensive means before the submarine would be able to execute an attack. At the present moment it would appear that the most dangerous enemy of the submarine yet discovered is the airplane or the dirigible. Some figures as to the mortality among submarines due to the efforts of aircraft have been published in an earlier chapter. The chief value of aircraft in this work is due to the fact that objects under the water are readily discernible at a considerable depth when viewed from a point directly over them. An illustration familiar to every boy is to be found in the fact that he can see fish at the bottom of a clear stream from a bridge, while from the shore the refraction of the water is such that he can see nothing. From the air the aviator can readily see a submarine at a depth of 50 feet, unless the water is unusually rough or turbid. The higher he rises, the wider is his sphere of vision. With the lurking craft thus located, the airman can either signal to watching destroyers or may bide his time and follow the submarine until it rises to the surface, when a well-placed bomb will destroy it. Both of these methods have been adopted with success. For a time the submarines were immune from this form of attack because of the difficulty of finding a bomb which would not explode on striking the surface of the water, thus allowing its force to be dissipated before it reached the submarine, or else would not have its velocity so greatly checked by the water that on reaching the submarine the shock of its impact would not be great enough to explode it at all. Both of these difficulties have been overcome. The new high explosives have such power, taken in connection with the fact that water transmits the force of an explosion undiminished to a great distance, that many of them exploding at the surface will put out of action a submarine at a considerable depth. Furthermore, bombs have been invented which, being fired, not merely dropped from an airplane, will go through the water with almost undiminished momentum, and explode on striking the target, or after a period fixed by the assailant. Other bombs, known as depth bombs, are fitted with flanges that revolve as they sink, causing an explosion at any desired depth. About the actual achievements of the airplane as a foe to submarines there hangs a haze of mystery. It has been the policy of the Allied governments to keep secret the record of submarines destroyed and particularly the methods of destruction. But we know that a few have met their fate from bolts dropped from the blue. In The Outlook, Lawrence Latourette Driggs, himself a flying man of no contemptible record, describes the method and result of such an attack. After recounting the steps by which a brother airman attained a position directly above a submerged submarine preparatory to dropping his bomb, he says, "Down shot his plummet of steel and neatly parted the waters ahead of the laboring submarine. But it did not explode. I could see a whirling metal propeller on the torpedo revolve as it sank. It must have missed the craft by 20 feet. Suddenly a column of water higher than my position in the air stood straight up over the sea, then slipped noiselessly back. By all that is wonderful, how did that happen?" As we covered the spot again and again in our circling machines we were joined by 2 more pilots, and finally by a fast clipper steam yacht. The surface of the water was literally covered with oil, breaking up the ripple of the waves and smoothing a huge area into gleaming bronze. Here and there floated a cork belt, odd bunches of cotton waste, a strip of carpet, and a wooden 3-legged stool. These fragments alone remain to testify to the corpus delicti. "Philip," I said, half an hour later, as the hot coffee was thawing out our insides, "what kind of a civilized bomb do you call that?" "That bears the simple little title of trinitrotoluol. Call it TNT for short," replied Sergeant Pierron. "But what made it hang fire so long?" I demanded. "It's made to work that way. When the bomb begins sinking, the little propeller is turned as it is pulled down through the water. It continues turning until it screws to the end. There it touches the fuse pin and that sets off the high explosive, at any depth you arrange it for." I regarded him steadfastly. Then I remarked, "But it did not touch the submarine. I saw it miss." "Yes, you can miss it 50 yards and still crush the submarine." He took up an empty eggshell. The submarine is hollow like this. She is held rigidly on all her sides by the water. Water is non-compressible like steel. Now, when the TNT explodes, even some distance away, the violent expending concussion is communicated to this hollow shell just as though a battering ram struck it. The submarine can't give any because the surrounding water holds her in place. So she crumbles up like this. Piran opened his hands and the flakes of eggshell fluttered down until they struck the floor. Gunfire undoubtedly is still the most reliable preventive against submarine attacks. Comparatively small calibered guns can cause serious damage to submarines even by one well-directed shot. Submarines have been sunk both by warships and merchantmen in this way, and many more have been forced to desist from attacks. Not every merchantman, of course, can be equipped with the necessary guns and gunners. Neither equipment nor men can be spared in sufficient quantities. But the efficiency of gun protection has been proved beyond all doubt by many authentic reports of successful encounters between armed merchantmen and submarines in which the latter were defeated. Ramming, too, has been advocated and tried. It is, however, a procedure involving considerable danger to the attacking boat. For one thing, all the submarine has to do is to dive quick and deep enough and is out of harm's way. Then, too, the chances are that the submarine can launch a torpedo in time to reach the ramming vessel before the latter can do any damage. There have been reports of submarine duels between Austrian and Italian submarines in the Adriatic, in which it was claimed that in each at least one submarine was destroyed, and at least in one instance both the duelists were sunk. Generally speaking, the fact has been established, however, that submarines cannot fight submarines with any degree of success, except in exceptional cases and under exceptional conditions. Since the outbreak of the war between the United States and Germany, the question of combating the submarine has become more acute than ever. The latest development has been along negative rather than affirmative lines. It has apparently been decided that none of the devices known at present and capable of destroying submarines is sufficient either alone or in combinations to defeat the submarines decisively. The best means of balancing as much as possible the losses which German submarines are inflicting on the shipping facilities of the Allies at the present seems to be the unlimited and prompt building of large fleets of comparatively small ships. If this can be accomplished in time, the German submarines undoubtedly will find it impossible to destroy a tonnage sufficient to exert any great influence on the final outcome of the war. End of Submarine Warfare, Part 3. Recording by William Tomcho. Chapter 17 of Aircraft and Submarines by Willis J. Abbott. This LibriVox recording is in the public domain. Recording by William Tomcho. The Future of the Submarine, Part 1. The world will not always be at war. Interminable as the conflict by which it is now racked seems, and endless as appears the resources of the nations participating in it, the time must come when victory or sheer exhaustion shall compel peace. People talk of that peace being permanent. That is perhaps too sanguine a dream while human nature remains what it is, and nations can still be as covetous, ambitious, and heedless of others' rights as are individuals. But beyond doubt a prolonged period of peace awaits the world. What then is to be the future of the aircraft and the submarine which had to wait for war to secure any recognition from mankind of their prodigious possibilities? Of the future of the aircraft there can be no doubt. Its uses in peace will be innumerable. Poor old Count Zeppelin, who thought of his invention only as a weapon of war, nevertheless showed how it might be successfully adapted to the needs of peace merely as a by-product. As for the airplane, both for sport and business, its opportunities are endless. Easy and inexpensive to build, simple to operate with but little training on the part of the aviator, it will be made the common carrier of all nations. Already the United States is maintaining an aerial mail service in Alaska. Already, too, bi- and triplanes are built capable of carrying 25 to 30 men besides guns and ammunition. It is easy to foresee the use that can be made of machines of this character in times of peace. Needing no tracks or right-of-way, requiring no expensive signaling or operative system, asking only that at each end of the route there shall be a huge level field for rising and for landing, these machines will in time take to themselves the passenger business of the world. But the future of the submarine is more dubious. Always it will be a potent weapon of war. It may indeed force the relegation of dreadnoughts to the scrap heap, but of its peaceful services there is more doubt. That it can be made a cargo carrier is unquestionably true, but to what good? There is no intelligent reason for carrying cargoes slowly under water which might just as well be carried swiftly on the surface unless war compels concealment. Underwater navigation must always be slower and more expensive than surface navigation, nor does it seem probable that the underwater boats can ever equal in size ordinary ships, though undoubtedly their present proportions are going to be greatly increased. As a result of the German submarine campaign, it is possible that the United States may develop a fleet of underwater merchantmen to circumvent the enemy while this war continues, though there has been but little discussion of it. But, even so, common sense would indicate that such a fleet would be abandoned on the restoration of peace. If anything is to be done toward making the submarine a vessel of ordinary everyday use, the present double system of motors, the Diesels for surface navigation and the electric for submerged service, will have to be abandoned. Inventors, however, are diligently working on this problem today. Indeed, so well known and successful a builder of submarines as Mr. Simon Lake seemed to have faith in their possibilities as merchant craft. As early as February 1916 he announced that he had taken out a patent on a new form of cargo-carrying submarine which he described as made up of nests of light-weight circular tanks of comparatively small diameter surrounded by a ship-shaped form of hull. What advantage was to accrue from this type of vessel Mr. Lake has not explained. However, the Germans, who seemed to originate everything successfully, demonstrated that the merchant submarine was a practicable and useful craft with which to beat the blockade. This was proved by the two successful trips made by the unarmed German merchant submarine Deutschland between Germany and the United States in 1916. Loaded with a cargo of dyestuffs and chemicals, she left Bremen on June 14, 1916, and arrived in Baltimore early in July. After a short stay, during which she took on a full return cargo, consisting chiefly of rubber and metal, she started on August 1, 1916, for her return trip to Bremen, where she arrived safely soon after August 15, 1916. Once more, in October of the same year, she made a successful round trip, docking this time in New London. There was considerable talk about additional trips by other German merchant submarines, but none of them were ever carried out. It has never become known whether this was due to the loss of these merchant submarines or to political relations between Germany and the United States, which were then gradually assuming a less friendly form. Of course, it is true that such boats are blockade runners and in a way, therefore, part and parcel of warfare. But they are unarmed merchantmen just the same, and their exclusively mercantile character has been officially acknowledged by the United States government. Under conditions of peace, however, it is very doubtful whether submarine merchantmen would play, nor does it seem as if they possessed, any advantages at all over surface merchant vessels. Nevertheless, they represent an entirely new development of submarine navigation, and therefore deserve attention. During her stay in the United States, very few people were permitted to get more than a glance of the Deutschland. As a result, comparatively little became known regarding her mechanical details. The Scientific American, however, in its issue of July 22, 1916, gives a fairly detailed description of this first merchant submarine. From this account we learn that the Deutschland conforms rather closely to the typical German naval U-boat. The hull proper consists of an internal cigar-shaped cylindrical structure, which extends from stem to stem, and in its largest diameter measures about 20 feet. Enclosing this hull is a lighter false hull which is perforated to permit the entrance and exit of the sea water and is so shaped as to give the submarine a fairly good ship model for driving at high speed on the surface and at a much lesser speed submerged. The upper portion of the false hull does not present such a flat deck-like appearance as is noticeable in the naval U-boats. In fact, the whole modelling of the Deutschland, as compared with the naval boats, suggests that she has been fulled out somewhat, with a view to obtaining the necessary displacement for cargo carrying. The interior cylindrical hull is divided by 4 transverse bulkheads into 5 separate watertight compartments. Compartment number 1, at the bow, contains the anchor cables and electric winches for handling the anchor, also general ship stores and a certain amount of cargo. Compartment number 2 is given up entirely to cargo. Compartment number 3, which is considerably larger than any of the others, contains the living quarters of the officers and crew. At the after end of this compartment, and communicating with it, is the conning tower. Compartment number 4 is given up entirely to cargo. Compartment number 5 contains the propelling machinery, consisting of 2 heavy oil engines and 2 electric motors. The storage batteries are carried in the bottom of the boat, below the living compartment. For purposes of communication, a gangway 2 feet 6 inches wide by 6 feet high is built through each cargo compartment, thus rendering it possible for the crew to pass entirely from one end of the boat to the other. The length of the Deutschland is about 315 feet, beam 30 feet, and draft 17 feet. For surface propulsion and for charging the batteries, the boat carries 2 4-cylinder diesel heavy oil motors of about 600 horsepower each. The speed at the surface is from 12 to 13 knots, and submerged it is 7 knots. At the surface, the displacement of the boat is about 2,000 tons, and she has a cargo capacity of about 700 tons. The freeboard to the main deck, which runs the full length of the boat but is only about 5½ feet wide, is about 6 feet, and the cockpit at the top of the conning tower is about 15 feet above the water. This cockpit, by the way, is suggestive of the protection afforded a chauffeur in an automobile, there being a shield in front of the quartermaster, so shaped as to throw the wind and spray upwards and clear of his face. 2 periscopes are provided, one at the forward end of the conning tower, and the other, of larger diameter, being forward and on the starboard of the conning tower. An interesting feature of the 2 folding steel wireless masts, about 50 feet in height, both of which fold aft into the pockets built in the deck of the ship. The forward one of these masts carries a crow's nest for the lookout. The commander of the Deutschland, Captain Paul Koenig, was before the war a popular captain of North American Lloyd liners. He has published a very vivid and interesting account of the Deutschland's trip, The Voyage of the Deutschland. In this book he tells us how he was offered this novel command while the plans were still being drawn, and that he immediately accepted, making, however, the proviso, if the thing really comes off. The men backing the venture lost no time, and, so Captain Koenig tells us, in less than 2 months a telegram called me to Berlin to an important conference. Here I looked at sketches, plans, and working drawings until my eyes swam. 4 more months passed which I utilized to the full. I then went to Kiel and saw a remarkable framework of steel slowly take shape upon the stocks across the way at Gardend. Rotund, snug, and harmless, the thing lay there. Inside it were hidden all the countless, complicated, and powerful features of those sketches and working drawings. I cannot boast that the reality as executed in steel and brass was any easier to grasp than the endless network of lines and circles which had bewildered me when inspecting the blueprints. Those of you who have seen illustrations and photographs of the interior of the central station or the turret of a submarine will understand what I mean. And should you have entered a submarine itself and felt yourself hopelessly confused by the bewildering chaos of wheels, vents, screws, cocks, pipes, conduits, above, below, and all about, and to speak of the mysterious levers and weird mechanisms, each of which has some important function to fulfill, you may find some consolation in the thought that my own brains performed a devil's dance at the sight. But after this monster, with its tangle of tubes and pipes, had been duly christened, and its huge gray-green body had slid majestically into the water, it suddenly became a ship, It swam in its element as though born to it, as though it had never known another. For the first time I trod the tiny deck and mounted the turret to the navigation platform. From here I glanced down and was surprised to see beneath me a long, slender craft, with gracious lines and dainty contours. Only the sides, where the green body vaulted massively above the water, gave an indication of the huge size of the hull. I felt pride and rapture as my eye took in this picture. The fabric swayed slightly beneath my feet, an impressive combination of power and delicacy. And now I know that what had at first seemed to me nothing more than the product of some mad fantasy on the part of the technicians was in reality a ship. It was a ship in which oceans might be crossed, a real ship to which the heart of an old sailor like myself might safely attach itself. Then came a short period of trial trips and diving tests, all of which were carried off successfully. And at last the day of departure arrived. As soon as the last escort had turned around, a final diving test was ordered. Instantly the response came back from the turret and the central station, and the men hurried to their posts. The oil engines were still hammering away at a mad rate. I left the manhole of the turret. The cover was battened down. The engines stopped at the same moment. We felt a slight pressure in our ears for a moment. We were cut off from outside and silence reigned, but this silence was merely an illusion, and was due to the change. Upon the diving valves, submerge! The valves were flung open, and the compressed air escaped hissing from the tanks. At the same time a gigantic, intermittent snorting ensued, like the blowing and belching of some prehistoric monster. There was an uncomfortable pressure in our ears, then the noise became more regular, followed by a buzzing and a shrill hum. All the high notes of the engines in the central station intermingled and made a bewildering noise. It was like a mad diabolical sing-song. And yet it was almost like silence after the dull, heavy pounding of the oil motors, only more insistent and irritating. The penetrating hum in the various vents announced the fact that the diving mechanism was in operation. It moaned and sang lower and lower in the scale of tones. These slowly diminishing and steadily deepening tones give one the physical feeling of mighty volumes of water pouring in and flooding full. You have the sensation of growing heavier and sinking as the boat grows heavier and sinks, even though you may not be able to see through the turret window or the periscope how the bows are gradually submerged and the water climbs higher and higher up the turret until all things without are wrapped in the eerie twilight of the depths. The faithful lamps burned, however, and then a real silence suddenly ensued. There was no sound but the gentle trembling rhythm of the electric engines. I then gave the order, "Submerge to 20 meters." Both engines half steam ahead. I was able to follow our submersion by means of the manometer. Through flooding the tanks, the boat is given several tons overweight, and the enclosed ship space is made heavier than the displaced quantity of water. The titanic fish, therefore, began to sink downward in its element. That is to say, it began, in a certain sense, to fall. At the same time the electric engines are put into motion, and the propulsive force of the propellers acts upon the diving rudders and causes the sinking to become a gliding. After the required depth has been reached, something which may easily be read from the manometer that records the depth, all further sinking may be stopped by simply lightening the hull, which is done by forcing out some of the water in the submarine's tanks. The furious growling of the pump is always a sure sign that the required depth is being approached. The noise ceased. Only the electric motors continued to purr, and the word came from the central station, 20 meters, even keel. Rudder set. So we forged ahead at a depth of 20 meters. Of course we are blind under such conditions, and can regulate our movements only by means of the depth recorder and that precious little jewel of the boat, our compass. No ray of light reached us any longer from without. The periscope was submerged long ago, and the steel safety covers over the windows were closed. We had been metamorphosed completely into a fish. Orders were then given to rise again. The Deutschland carried out this maneuver with the same facility with which she had taken the initial dive of her long voyage. In record time the ballast tanks were emptied and the change from electric motors to oil engines was completed without further loss of time. The boat was started at top surface speed towards her ultimate goal, the United States. On the following day the Deutschland barely escaped running foul of a British submarine chaser, disguised as a neutral merchantman. A quick dive alone saved her. When she came up again a wild storm and a heavy sea were raging. Even before the change from the electric motors to the oil engines had been completed, another dangerous-looking vessel appeared and before long was recognized as a hostile destroyer by Captain Koenig. He tells us that he made one jump into the turret and slammed the cover fast. "Alarm! Dive quickly! Flood! Set diving rudder! 20 meters depth!" The commands were uttered in almost one breath, but the execution of them. To attempt to dive with such a sea running was sheer madness, as experience has taught us. What was I to do? The destroyer might have seen us already. Well, we knew we must get under, and as quickly as possible. The men in the central below me were working away in silent haste. All the exhausts were opened wide, the compressed air hissed from the tanks, the diving vents were chanting in all possible keys. I stood with my lips pressed together and stared out of the turret window upon the tossing sea, and watched for the first sign of our going down. But our deck remained still visible, and we were continually lifted into the air by some wave. There was not a moment to be lost. I ordered the diving rudder to be set still more sharply and both engines to drive ahead with full power. The whole vessel quivered and thrilled under the increased pressure of the engines and made several leaps. She staggered about in the furious seas, but still seemed loath to leave the surface. Then she gave a jerk and her bows suddenly dipped and cut into the flood. She began to sink into the depths at an ever-increasing angle. The coming daylight vanished from the windows of the turret. The manometer in rapid succession showed 2, 3, 6, 10 meters depth, but the angle of the boat also began to increase. We staggered about, leaned back, slipped off our feet. We then lost our footing entirely, for the floor of the Deutschland slanted sharply toward the front. I was just able to catch hold of the ocular or eyepiece of the periscope. Down in the central the men were hanging on to the hand wheels of the diving rudder. A few terrible seconds passed thus. We had not yet seized the full significance of this new situation when there came a severe shock. We were hurled to the floor, and everything that was not fastened down went flying in all directions. We found ourselves in the queerest attitudes, and stared into one another's faces. There was a grim silence for a moment, then First Officer Crapolle remarked dryly, "Well, we seem to have arrived." This broke the ghastly tension. We were all rather pale around the gills, but at once tried to get our bearings. What had happened? What had caused this unnatural inclination of the boat, and why were the engines above us raving at intervals in a way that made the whole boat roar from stem to stern? Before any of us had arrived at any solution of the mystery, our chief engineer, little Cleese, had jumped up from his crouching position and, swift as lightning, had swept the engine signal dial around to "stop." And suddenly there was a deep silence. We slowly assembled our proper legs and arms and thought hard over what had happened. The vessel had slanted down toward the bows at an angle of about 36 degrees. She was standing, so to speak, on her head. Our bow was fast upon the bottom of the sea. Our stern was still oscillating up and down like a mighty pendulum. The manometer showed a depth of about 15 meters. However, the Deutschland finally worked herself free and soon was again on the surface. Luck must have been with her, for she had suffered no damage, and in spite of the mountains of water which she must have thrown up, the hostile destroyer had not discovered her. Once more she was off on her way. End of The Future of the Submarine, Part 1. Recording by William Tomcho. Chapter 17 of Aircraft and Submarines by Willis J. Abbott. This LibriVox recording is in the public domain. Recording by William Tomcho. The Future of the Submarine, Part 2. So the days went by, and before long the merchant submarine had passed, without having been detected, beyond the territory in which British patrol boats were operating. Then came a succession of uneventful days and fine weather. Practically every day diving tests were made. One of these the captain describes as follows: "During these experimental diving tests we were treated to a spectacle of fairy-like loveliness. I had set the rudder in such a way that the turret was traveling about 3 yards under water. Overhead the sun shone brilliantly and filled the deeps with a clear radiance. The pure water was luminous with color. Close at hand it was of a light azure blue, of fabulous clearness and transparent as glass. I could see the entire boat from the turret windows. The shimmering pearls of the air bubbles which rise constantly from the body of the craft played about the entire length of the vessel from deck to bows, and every detail stood out in miraculous sharpness. Farther ahead there was a multicolored twilight. It seemed as if the prow kept pushing itself noiselessly into a wall of opalescent green which parted, glistening, and grew to an ethereal, rainbow-like translucency close at hand. We were spellbound by this vision of beauty. The fairy-like effect was increased by medusæ which, poised in the transparent blue, frequently became entangled in the wires of the mine guards or the railings and glowed like trembling fires of rose, pale gold, and purple. But less pleasant things were in store for the Deutschland's crew. The nearer the boat came to the region of the Gulf Stream, the more violent the weather became. Though she still ran most of the time on the surface, it became necessary to keep all openings battened down. Even the manhole leading to the turret could be kept open only for short periods. Naturally the temperature was rising all the time. It was midsummer, and the Gulf Stream contributed its share of warmth. No wonder, therefore, that Captain Koenig compares conditions below decks to a veritable hell, and then continues: "While in the Gulf Stream we had an outer temperature of 28° Celsius. This was about the warmth of the surrounding water. Fresh air no longer entered. In the engine room 2 6-cylinder combustion motors kept hammering away in a maddening 2/4 time. They hurled the power of their explosions into the whirling crankshafts. The red-hot breath of the consumed gases went crashing out through the exhausts, but the glow of these incessant firings remained in the cylinders and communicated itself to the entire oil-dripping environment of steel. A choking cloud of heat and oily vapor streamed from the engines and spread itself like a leaden pressure through the entire ship. During these days the temperature mounted to 53° Celsius. And yet men lived and worked in a hell such as this. The watch off duty, naked to the skin, groaned and writhed in their bunks. It was no longer possible to think of sleep, and when one of the men fell into a dull stupor, then he would be aroused by the sweat which ran incessantly over his forehead and into his eyes, and would awake to new torment. It was almost like a blessed deliverance when the 8 hours of rest were over and a new watch was called to the central or the engine room. But there the real martyrdom began. Clad only in an undershirt and drawers, the men stood at their posts, a cloth wound about their foreheads to keep the running sweat from streaming into their eyes. Their blood hammered and raced in their temples. Every vein boiled as with fever. It was only by the exertion of the most tremendous will power that it was possible to force the dripping human body to perform its mechanical duty and to remain upright during the 4 hours of the watch. But how long would we be able to endure this? I no longer kept a log during these days, and I find merely this one note: temperature must not rise any higher if the men are to remain any longer in the engine room. But they did endure it. They remained erect like so many heroes. They did their duty, exhausted, glowing hot, and bathed in sweat, until the storm center lay behind us, until the weather cleared, until the sun broke through the clouds, and the diminishing seas permitted us once more to open the hatches. The Deutschland was now near her goal. Without any trouble she entered Hampton Roads and was docked at Baltimore. There her cargo was discharged and her return cargo loaded. This latter operation involved many difficulties. During her stay a United States government commission made a detailed inspection of the Deutschland to determine beyond all question her mercantile character. But at last the day of departure, August 1st, had arrived. Properly escorted, she made the trip down the Patapsco River and Chesapeake Bay. On her way down she made again diving trials, which Captain König describes as follows: "In order to see that everything else was tight and in good order, I gave the command to set the boat upon the sea bottom at a spot which, according to the reading upon the chart, had a depth of some 30 meters. Once again everything grew silent. The daylight vanished, the well known singing and boiling noise of the submerging vents vibrated about us. In my turret I fixed my eyes upon the manometer. 20 meters were recorded, then 25. The water ballast was diminished, 30 meters appeared, and I waited the slight bump which was to announce the arrival of the boat at the bottom. Nothing of the sort happened. Instead of this, the indicator upon the dial pointed to 32, to 33, to 35 meters. I knocked against the glass with my finger. Correct. The arrow was just pointing toward 36. "Great thunder! What's up?" I cried, and reached for the chart. Everything tallied. 30 meters were indicated at this spot, and our reckoning had been most exact. And we continued to sink deeper and deeper. The dial was now announcing 40 meters. This was a bit too much for me. I called down to the central and got back the comforting answer that the large manometer was also indicating a depth of over 40 meters. The two manometers agreed. This, however, did not prevent the boat from continuing to sink. The men in the central began to look at one another. Ugh! It gives one a creepy feeling to go slipping away into the unknown amidst this infernal singing silence and to see nothing but the climbing down of the confounded indicator upon the white-faced dial. There was nothing else to be seen in my turret. I glanced at the chart and then at the manometer in a pretty helpless fashion. In the meantime the boat sank deeper. 45 meters were passed. The pointer indicated 48 meters. I began to think the depth of the Chesapeake Bay must have some limit. We surely could not be heading for the bottomless pit. Then the boat halted at a depth of 50 meters without the slightest shock. I climbed down into the central and took counsel with Cleese and the two officers of the watch. There could be only one explanation. We must have sunk into a hole which had not been marked upon the chart. When orders were now given to rise, it was found that the exhaust pumps refused to work. After a while, however, the chief engineer succeeded in getting them started. They reached the surface after about 2 hours of submergence. It was dark by the time the merchant submarine was approaching the 3-mile limit. Outside of it, hostile warships were lying in wait. That the Deutschland escaped them well illustrates the fact that submarines may be kept by various means from entering a bay or a harbor, but that to blockade their exit is practically impossible. This is how Captain König speaks of his escape. "We knew that the most dangerous moment of our entire voyage was now approaching. We once more marked our exact position, and then proceeded to make all the preparations necessary for our breaking through. Then we dived and drove forward. All our senses were keyed to the utmost, our nerves taut to the breaking point with that cold excitement which sends quivers through one's soul, the while outwardly one remains quite serene, governed by that clear and icy deliberation which is apt to possess a man who is fully conscious of the unknown perils toward which he goes. We knew our path. We had already been informed that fishermen had been hired to spread their nets along certain stretches of the 3-mile limit, nets in which we were supposed to entangle ourselves, nets into which devilish minds had very likely been woven. Possibly these nets were merely attached to buoys which we were then supposed to drag along after us, thus betraying our position. We were prepared for all emergencies, so that in case of extreme necessity we should be able to free ourselves of the nets. But all went well. It was a dark night. Quietly and peacefully the lighthouses upon the two capes sent forth their light, the while a few miles further out death lay lowering for us in every imaginable form. But while the English ships were racing up and down, jerking their searchlights across the waters and searching again and again in every imaginable spot, they little surmised that at times within the radius of their own shadows a periscope pursued its silent way, and under this periscope the U Deutschland. That night at 12 o'clock, after hours of indescribable tension, I gave the command to rise. We had broken through. Slowly the Deutschland rose to the surface. The tanks were blown out and the Diesel engines flung into the gearing. At our highest speed we now went rushing toward the free Atlantic. The homeward voyage was completed without untoward incident, and long before the month had ended the first, and probably last, merchant submarine was again safe and snug in her home port. The cargo carrying submarine, however, is by no means the only type of underwater vessel engaged in peaceful pursuits which has been suggested so far. Mr. Simon Lake, the American submarine engineer and inventor, has frequently pointed out the commercial possibilities of the submarine. In the early part of 1916 a series of articles from his pen appeared in International Marine Engineering. They contained a number of apparently feasible suggestions looking towards the commercial development of the submarine. First of all, he tells of experiments made with submarines for navigation under ice. The proper development of this idea, of course, would be of immense commercial value. Many harbors in various parts of the world are inaccessible during the winter months for vessels navigating on the surface. Navigation on many important inland lakes likewise has to be stopped during that period. Submarines, built so they can safely travel under the ice, would overcome these conditions and would make it possible to use most ice-bound ports throughout the entire year, at least in Mr. Lake's view. Ever since Mr. Lake began inventing and building submarines he had been interested in the possibilities which submarines offer for the exploration of the sea bottom and for the discovery of wrecks and recovery of their valuable cargoes. His first boat, the Argonaut, as we have heard, possessed a diving chamber for just such purposes. He had continued his investigations and experiments along this line, and in these articles he shows illustrations of submarine boats and devices adapted for such work. Properly financed and directed, the recovery of cargoes from wrecks undoubtedly would not only bring large financial returns to the backers of such a venture, but also do away with the immense waste which the total loss of sunken vessels and cargoes inflicts now on the world. Submarines in peace may yet recover for the use of man much of the wealth which submarines in war have sent to the bottom of the sea. Marine insurance, too, would be favorably affected by such an undertaking. Still, one other commercial submarine boat is advocated by Mr. Lake. This is to be used for the location and collection of shellfish on a large scale. Of this vessel its inventor says: "The design of this submarine oyster dredging vessel is such that the vessel goes down to the bottom direct, and the water is forced out of the center raking compartment so that the oysters may be seen by the operator in the control compartment. With only a few inches of water over them, headway is then given to the submarine and the oysters are automatically raked up, washed, and delivered through pipes into the cargo carrying chambers. Centrifugal pumps are constantly delivering water from the cargo compartments, which induces a flow of water through the pipes leading from the rake pans with sufficient velocity to carry up the oysters and deposit them into the cargo holds. In this manner the bottom may be seen, and by tracking back and forth over the bottom the ground may be cleaned up at one operation. This boat has a capacity of gathering oysters from good ground at the rate of 5,000 bushels per hour. The use of the submarine will make the collection of oysters more nearly like the method of reaping a field of grain, where one swath systematically joins on to another and the whole field is cleaned up at one operation. Man's greediness for profit has already driven the salmon from the rivers of New England, where once they swarmed. Mechanical devices for taking them by the hundreds of thousands threaten a like result in the now teeming rivers of Washington and British Columbia. Mr. Lake's invention has the demerit of giving conscienceless profiteers the opportunity to obliterate the oyster from our national waters. It does not appear, however, that, except as an engine of war, the submarine offers much prospect of future development or future usefulness. And as we of the United States entered this war, which now engages our energies and our thoughts, for the purpose of making it the last war the world shall ever know, speculation on the future of the submarine seems rather barren. That does not mean, however, that there will be a complete stoppage of submarine construction or submarine development. War is not going to be ended by complete international disarmament, any more than complete unpreparedness kept the United States out of the struggle. A reasonable armament for every nation, and the union of all nations against any one or two that threaten wantonly to break the peace is the most promising plan intelligent pacifism has yet suggested. In such an international system there will be room, and plenty, for submarines. Indeed, it is into just such a plan that they intelligently fit. Though not wholly successful in their operations against capital ships, they have demonstrated enough power to make nations hesitate henceforth before putting a score of millions into ponderous dreadnoughts which have to retire from submarine-infested waters, as the British did in their very hour of triumph at Jutland. They have not nullified, but greatly reduced the value of overwhelming sea power such as the British have possessed. A navy greater than those of any two other nations has indeed kept the German ships, naval and commercial, locked in port, but less than 200 inexpensive submarines bid fair to sweep the seas of all merchant ships, neutral as well as British, unless by feverish building the nations can build ships faster than submarines can sink them. Huge navies may henceforth be unknown. The submarine has been the David of the war. It is a pity that its courage and efficiency have been exerted mainly in the wrong cause, and that the missiles from its sling have felled the wrong Goliath. Aircraft and submarine. It is still on the cards that when the definitive history of the war shall be written, its outcome may be ascribed to one or the other of these novel weapons. The creation of American inventive genius. End of the Future of the Submarine, Part 2. End of Aircraft and Submarines, by Willis J. Abbott. Recording by William Tomcho.